Dear colleagues, let me open to 25th International Conference Distributed Computer and Communication Networks. The welcome speech will be presented by Director of AMCT Institute, RUDN, Professor Samuilov Konstantin Evgenievich. Let me read it. It's a great honor for me to open the conference, to host this conference, because I'm a hosting person together with my colleagues, organizing committee, and Rudny University this year is a hosting university. I remember you that we have organizers of this conference, and I will say a few words about the conference. And I'm very grateful to our guests from abroad that you are visiting Russia, visiting our conference, and visiting our university in Moscow. So, dear colleagues and friends, ladies and gentlemen, I'm pleased and honored to open the 25th anniversary of International Conference on Distributed Computer and Communications Networks, DCCN. That is 25th anniversary. It's a great event for us. 25 years from it's about 1995, I guess, because first years, not every year, we organize the conference. It is a great honor indeed because the level of conferences organizers of its program committee and participants who have submitted over 120 papers is extremely high. After thorough double-blind peer review, 96 papers were accepted, included into the conference program, and will be presented during this week at the conference sessions. You all have the conference program in your hand. I will just remind you that the main organizer of DCCN is leading Russian institute in the area of control information technology and computing, Trapeznikov Institute of Control Science of Russian Academy of Science, and here my friend, our friend, Professor Vladimir Vishnevsky. Actually, he is main person who organized this conference more than 25 years ago, and I'm very grateful to Vladimir, our great friend and organizer of the conference. DCCN is also few of the Tomsk University faculties. To our foreign friends, I should say that Tomsk University is, I think, in top five universities of Russia. That is the first university in Siberia founded by Tsar Alexander, I remember the third, yes, maybe, in the end of 19th century. So two of the Tomsk University's faculties are represented at the conference this year. First, the Faculty of Applied Mathematics and Cybernetics, and the Faculty of Informatics. Rudny University, People's Friendship University of Russia, and Tomsk University have been partners for many years. Finally, DCCN is co-organized by the Institute of Information and Communication Technologies of Bulgarian Academy of Sciences, SAFI. It's also our old chaps, let's say, yes, Vladimir. And every year they support us with their efforts. On behalf of the conference presidium and myself, I would like to express profound gratitude for their cooperation to the members of the International Program Committee, chaired together with me by International Academy of Russian Scientists. First of all, again, about Vladimir, Professor Vladimir Vishnevsky. The research teams under their direction have been collaborating for over 25 years, not only in science, but also in training highly qualified professionals. I mean, in higher school, in Moscow universities and Russian universities all over the Russian Federation. The program committee includes renowned experts and research from 17 countries, namely Austria, Australia, Azerbaijan, Bangladesh, Belarus, Brazil, Bulgaria, China, France, Greece, Hungary, Israel, India, Italy, Latvia, Russia, and the United States. In today's plenary session and tomorrow, we will here, let me say, outstanding keynote speakers. Not tomorrow, but only today. We have four speakers, and I'm very pleased to shortly introduce them to you. First, Prof. Niraj Kumar, Department of Computer Science and Engineering, Tapar Institute of Engineering and Technology, India. Second, Prof. Dujanta Nali, Cope Labs, Lusafona University, Portugal. Both of presentation will be made online using Teams tools. A few words more, then I should introduce you Professor Amar Bukhana, here from the Bonch Bruyevich St. Petersburg State University of Telecommunications, Russia. And finally, I will also present a keynote speech today. The DCCN proceedings will be published in the book included in the Russian Science Citation Index. Selected extended papers have been reviewed and accepted for publishing by Springer in 2 volumes and open, just as the director of Trapeznikov Institute, academician Novikov Dmitry. So thank you very much. That was my speech for opening, and we consider that conference is opened. After you, I will have a few words regarding the conference program. Please.
Thank you very much, Professor Samulov. Now we are starting the plenary report. Let me give the floor to the Professor Haraj Kumar from Thapa Institute of Engineering and Technology, India.
Well, for present, I say a few words regarding the conference program and our agenda. Today, we understand that we are working here. We will listen to 4 keynote speeches with a coffee break at about 3:30 p.m. Yes, 3:30. Please note that coffee break will be on the 2nd floor, and the throughput of elevators are not so good. Yes, so it will take time to go downstairs and to go upstairs. Please, we are waiting for everybody in time after the coffee break. So from tomorrow, okay, so we begin. Okay, hello, I'm Konstantin Samuilov. Yes, thank you very much for your maintenance, and the floor is yours. Please, you can start. We are listening to you very attentively. Please.
Okay. So I hope my presentation will be visible to all of you.
We can see your presentation. Everything is well. Please.
Okay. So very good afternoon to all of you. So first of all, I would like to thank the organizer to give me this opportunity to share my ideas on one of the most important technologies nowadays, which is called as digital twins and metaverse. So you see that we have technological revolutions from last few years, and in these technological revolutions, 2 of the most important revolutions is digital twins and metaverse. So we will discuss that how these digital twins and metaverse can be used for wide range of application in different domains. So we can start with this part, which shows that as far as digital twins are concerned, so it's all about how industrial revolutions has been taken care of and how this industrial revolution has been used in wide range of application, right, starting from industry 4.0 to industry 5.0, and then we have the other part associated in this revolution. So you can see that nowadays everybody is talking about the fast internet revolutions, and in these fast internet revolutions you can see that most of the times we are talking about different types of connection between different devices. So how this industrial revolutions has been used, that is the one of the core concerns nowadays as far as the digital twins are concerned. So in today's presentation, we will discuss that how this digital revolutions has been used in wide range of applications. So one of the most important applications nowadays is the augmented reality and virtual reality. So in this augmented reality scenario, you can see that we interact with the digital objects, and these digital objects are widely used in different scenarios. I mean to say here for different types of applications. So I hope this presentation is not visible to all of you or not. So digital twins are widely used for industrial revolutions, and you can see.
We don't see your screen.
Okay, just hold on. Just hold.
Professor, now we see your screen, yes, but not full screen.
Okay, so you can see that
Yes, actually.
digital twins are widely used for different applications. Like for example, it's a virtual mode where we can see that physical assets like we have product, we have process, system, or other facilities, and we can create a replica of digital assets of that particular object. So this digital twin can be used, I mean to say, in wide range of application where we can visualize the digital visualizations associated for a particular object. And along with this, we can do various types of data analytics, and then we can also apply machine learning algorithm or artificial intelligence based techniques for creating the replica of the digital objects. So obviously, in this regard, you can see Internet of Things plays an integral role for revolution of this digital twin technology. And most of the times you can see that most of the IoT based applications are using this digital twin technology for wide range of applications. So the prime reason for revolution of digital twins comes from the revolution from this part, which consisting of different aspects. Like for example, we can collect the data, and then this data can be collected from sensors, from different actuators or different controllers, which may be deployed across different applications. And then within this, we can have certain iterations. I mean to say here that we can go from state 1 to state 2, or we can go from state 2 to state 3. So you can see the first phase is all about how we can be able to connect and collect the data from different locations or from different applications. And when we collect the data from different applications, then this data can be collected from, I mean to say, using sensors or actuators, and we can be able to learn and analyze that particular data. And then once we able to perform certain data analytics technique on to perform learn and analyze that input data, but we can learn from that data, and then we can design certain triggers or events which will be used to generate alert and advice uh, to go or to perform, I mean to say, to improve that particular model. And then we in this phase, you can see we will be able to optimize different optimization algorithm, and then we can innovate and transfer. So this is all about a full life cycle of a digital twin for a particular application. So this application, let's say we will start with industrial manufacturing. So in this industrial manufacturing process, we will be consisting of different types of data analytics techniques and optimization of different types of variables. So how we will be able to optimize those variables and how we will perform different data analytics techniques so that we can solve the problem in real time with respect to the different data analytics techniques. So that is the core of application of any digital technology or digital twins can be used in this part. So this can be used in performing, I mean to say, you can perform or you can visualize the digital copy of an assets, and then before the actual deployment or actual product that is to be launched into the market, you can visualize the digital footprint of that particular object. And then if you have to perform certain analytics or if you want to make certain changes into that digital asset, so you can make it easily. So that's the one of the core, I mean to say here, core component of uses of digital twins in wide range of applications. So basically, if we segregate the digital twins from physical assets, so it's nothing but it's a cross-domain digital model that basically represents a production or process. And then using this product productions or process, we can perform certain data analytics techniques, and we can learn various types of parameters in real time for optimizations as well as to perform various business analytics. So basically, if we are able to represent the physical assets in the form of, I mean to say here, digitalization. So that is fall into the category of uses of this digital twin technology. So if we have to model any industrial IoT system, so we can model this industrial IoT system with the help of digital twins, and these are nothing but these are virtual replica of physical device that data scientists more or less performing various types of analytics in a particular domain or applications. So if we have to create the digital twins for any physical asset, so one thing is sure that we need to synthesize and collect the data from various sources, from manufacturing data. Then we will have to perform various types of operations on this data and performs various types of analytics from analytical softwares. And in this regard, AI algorithm can be one of the, we can say, core component that can be used to provide a virtual model by applying the data analytics techniques. And in this regard, digital technology or digital twins can be one of the possible solutions that can be revolutionized like anything. So if you visualize the revolution of digital twins, so from physical assets of a process, you can see that from physical assets of a process, we can collect the real-time data, and then this real-time data we can fed up in a digital model. So this physical assets along with digital data that has to be collected across from different devices like sensors and actuators. And once this data has been input to the digital model, then we will test out the performance of this digital model using various data analytics techniques. And once we apply the various types of data analytics techniques, so we come up with some sort of what we call as an output. And then in that sense, we can optimize the model, or we can fine tune those parameters which can enhance the performance of this model which we have designed for a particular application. And then the overall performance of, I mean to say, overall performance or working of this physical assets which has been working or in an industrial IoT system can be revolutionized in a smoothless manner. So we can perform various types of analytics on this digital model which we have created from the physical assets of the process, and using the digital data which has to be collected from different devices. So all in all, you can say it's all about how we can apply various knowledge driven techniques for performing data analytics techniques. And once we have performed various types of data analytics techniques, then these can be fed again to the physical model, or we can say physical assets can be, I mean to say, optimized, and we can get a digital copy of this original model, which can be revolutionized like anything. So these digital twins can be, I mean to say, there are 4 or 5 basic components which are used for performing analytics on digital twin variants. So you can see that the first important component is data. So data is all about we can say data is all about how we can collect the data from different devices, and this data can be from various types of safety applications. It consisting of what type of process we are using to collect the data, what type of equipment we are going to collect the data, what is the environment where this data has been collected, and then this data is to be fed into the model. This model is a process of sequential execution of different types of data analytics technique. And once this data has been fed into this digital model, then this digital model obviously would be executed. I mean to say, to perform certain types of analytics, and this model obviously can be a machine learning model. This model can be a deep learning voice models, and this can be various types of feature selections, and performing various types of analytics using the performance evaluation matrix. So all in all, you can see that this model performance needs to be check it out with respect to the artificial intelligence or physical simulations which needs to be performed on the input data which has been collected from different devices. And finally, you can see that after performing various types of data analytics techniques, we will be able to find out the final output or a digital copy of this product which is going to be design it out. So once we get the digital copy of the product which we are going to design it out, so we can make certain amendment into this process, and then once we make certain amendment with respect to the parameter selection or parameter optimization, then we can have certain level of iteration in the process. And once we have different types of iteration in the process, then we will be able to perform or execute, I mean to say, we can enhance the performance of the design model using this digital twin technology. So, this is the overall, I mean to say, a picture of how this digital twin can be used in different applications. So, different applications or use cases where we can use these digital twins can be manufacturing process. It can be different automobiles technology where we need to design the we can say blueprint of the let's say a vehicles or car. It can be used in aerospace applications where we need to control the operation of this rocket or other mission critical applications or devices. It can be used in healthcare applications also, where doctor can specify or take diagnosis of an individual persons as well. It can also be used in wind farm for taking out the energy management system, to design an energy management system for different applications. So I mean to say here that you can name any applications, and digital twins are there where we can have the virtual reality concept, and using that virtual reality concept we will be able to identify that how digital twins can be used in wide range of applications, starting from our household applications to the modern scientific applications. And as per the recent statistics, it shows that 85% of all IoT platforms will include such time of digital twinning. So you can just think about any applications, and all of those applications more or less are related to digital twin technology adaptations. And these digital twins technologies already have been used in wide range of application in our, starting from our smart home to the modern heavyweight digital manufacturing system, or for I mean to say modern IoT based applications as well. So there are certain inherent benefits also which can be seen by using of this digital twin in our day-to-day life applications. For example, it will use the total operational cost of any industrial IoT system, and Importantly, it can also improve the quality and yield of the final product, right, starting from the initial inception to the final output. And it will also increase the efficiency of the engineers who are making or who are involved in designing a digital product. So you can see in this particular process, industrial process goes obviously through various phases, and in each of these phases, there are various types of risk and various types of parameter or optimizations process occurs. And in this process, if if we are in this state of selection of appropriate parameters, then the final output would be very fine. So digital twins can be used in that scenario for optimization of different parameters and selection of different parameters as well. And it will also reduce the overall cycle cost and boost the overall productivity, because you see, if we are delivering a correct product in the market, then it will be beneficial for the industrial engineer as well to check out that the digital copy before the actual product is to be delivered to the system or delivered to the market itself. And it will also be used, can be used for diagnosis and fix various types of failures. It will can also be used to optimize the robot operational management system. So there are a number of applications where this digital twin can also be used for wide range of applications. But question here is why we are emphasizing on uses of digital twin. So because it is an emerging technology that can be used, I mean to say, in different types of asset managements, and this can be used for collecting and modeling of different industrial IoT systems. And along with this, these can also be used or integrate with different technologies in a seamless manner for providing for providing efficiency and providing I mean to say security, privacy, and ease of operations. So, and also it will also reduce the overall operational cost of any industrial IoT system, because if we can optimize different parameters during the process of optimization, then it will also increase the yield of the final output of the product as well. So it will decrease the overall cost as well. So so we can see that some components that are primarily associated for digital twin revolution is first of all data acquisitions part, that is more or less consisting of various types of industrial IoT systems like sensors, actuators, and other smart devices through which we can collect and analyze this data. And then there may be some different edge devices, there may be some 5G communication, 5G or 6G enabled communication devices. So this process is all about how will be able to acquire this data from different IoT devices. And then along with this, we will also have once we have collected this data, then this data must have some maybe stored on some remote locations, and cloud computing can be one of those solutions where we can store that particular data which can be collected from different IoTs or sensor devices. And then along with this machine learning or deep learning based tools, we will be able to provide certain level of analytics, certain level of predictions with respect to the input data that had been acquired from this data acquisitions part. So I mean to say here, there may be different sensors and actuators through which this data can be stored on cloud computing environment, and later on stages we will be able to provide different levels of analytics to form different types of analytics on this acquired data. And then once we will be able to perform different types of analytics, so we will be able to have digital models which can be used in digital manufacturing, in simulation technology with 3D scanning and photography for building information management, modeling, etc. Different types of process models which can be used to execute a digital twins. So the process here is that we will be able to build the models, and we will be able to connect and collect this data, and we can execute and optimize, and again we will provide certain level of optimization, certain level of innovations in terms of what we call as a parameter selections. And during this process you can see we will analyze this data, and then through this process in multiple times in different iteration we will be able to execute a model with respect to its performance evaluations in different dimensions for digital twin revolutions. So how these digital twins can be implemented? So digital twins can be implemented like this. So you can see that we will start with the digital twins, let's say starting with digital twins model formulations. We will be able to start with this operational part. We will be able to start with the optimization part. We will be able to start with the monitoring and controls, and then we will be able to have operational part associated for making the parameter selections and then optimize it with respect to different performance evaluation metrics. So this is the overall picture of any digital twin implementation for different applications. So if we will be able to start for implementation of any digital twins, so this can be done right starting from the project plan, and then we will be able to make a design for that particular plan, and we will be able to analyze the quality of the product that we are expecting at any point of time. So this is called as a project digital twins. So, and then using this project digital twins, we will iterate into multiple steps. I mean to say, right starting from plan, design, and right starting from the evaluation of the quality of this plan, we will be providing some green field in terms of project digital twins revolutions. But on the other side, if you build that particular model and provide these input parameters to that particular model, then this model can be executed in multiple iteration, and we can optimize different evaluation metrics. We can optimize different evaluation parameters. So this is called as a performance digital twins, and we will be able to having operational and maintenance part associated for this performance digital twins. And finally, once we have certain iterations, right starting from green field to this operational management field, so we will then switch to the final phase where we need to deploy this I mean to say need to deploy this project into real life scenario, and this is called as a project digital twin. So you can see that right starting from the initial I mean to say initial plan, where we can able to identify various types of performance evaluation metrics and make a chalk out a plan that how the final product will look like. We will be able to iterate into different I mean to say different stages, and during this each stage we will be able to identify that how we will be able to improve the overall performance of this digital twin base product, which is acting as a final product in any digital system. So there are three dimensions of digital twins, right starting from asset level to system level. So most of the digital twins in the market today is focused on individual asset, but with the correct interoperability and industry standard, they can be potentially be combined into an ecosystem of digital twin to supply chain, city, or even country level. And these can also be value throughout the life cycle. So digital twins add value to the life cycle of assets, process, system, or organization. So they can begin right starting at the design level through the use of design simulation twins, but practically digital twin can add value to any stage of asset, process, or system life cycle. So it's not there that we can start a digital twins at the initial level, but it can be applicable to any stage of the final product which we are going to design it out, or it is can be applicable in right starting from the initial state where we can form the initial software requirement specification document, or it can also be applied in design phase. It can also be applied in testing phase. So I mean to say that wherever we need to make certain level of optimization part with respect to the optimization of different evaluation metrics, so we will be able to provide certain level of abstraction. I mean to say in digital twin, and this can be used in different life cycle of digital twins, which can be used in different industrial manufacturing systems. So you can see at here that right starting from design and build part, and we have continuously hand over this particular part like design and build part. Again, we iterate to through this design and build phase. Similarly, we can operate and maintenance part can also be iterate in multiple levels. So uh, right starting from this particular phase, you can see design and build phase will becomes output of this particular phase will becomes an input for this operational and maintenance part. So it will increase the throughput, and it will also improve the overall product quality and yield a better product at the output at the final stage. So we can simulate what if scenario for new processes or parameters will happen, and this will model the demand supply requirement as well. So you can see that as far as design and build process is concerned, so we can performs the modeling and simulation part, and we can have construction sequence, we can have virtual commissioning as a designer, as a build, and as a maintenance part. And finally, at the level of operational and maintenance, we will be able to provide predictive maintenance, process optimization, energy management, real-time IoT data, which can be used to provide analytics and alerts for different types of fault into the system. So that can also be used like this. In this particular scenario, you can see, let's say we have some operating time for a industrial IoT system. So on the x-axis, you can see that we have some PF interval, that is process to failure system. So you can see that if we have to monitor the asset conditions or asset, I mean to say analyzer. So you can check it out from here that the failure of this asset will start from this location. And if we are able to identify this failure at this stage, and finally this failure will occur at this stage. So if we set out certain alerts in this particular process, in this manufacturing process, so we will be able to fix out first time fix rate for this failure at this stage. So this we can analyze that what is the mean time to failure, what is the mean time between different failures in this industrial IoT system, and we can also reduce the overall losses that may occur in this industrial IoT system. So I mean to say here that using the digital twin technology, we will be able to identify that we will be able to optimize these parameters like first time fix rate, mean time to failure, mean time between different failures, and losses that may occur while operating different types of operations, right starting from the initial stage of an asset creation to the final delivery of that asset to the end user. So in this manner, you can see that predictive modeling can be designed. So using the using this input data to the model as feature set, we will be able to predict the overall failure of an IoT system, and with the help of different AI based or machine learning based models. So you can see that this will gives a clear indication that how we can be able to identify the failure into the system, and with the help of predictive modeling or with the help of sequential modeling, we will be able to identify at what time this system may be able to crash it out at any instance of time. So this is one of the, I mean to say, one of the applications where digital twin can be used in an iterative manner to check out the health of an industrial IoT system. And with the help of predictive modeling, we will be able to identify that when the system is going to crash it out, right, starting from the failure that may occur either maybe in the form of hardware or software failure. So so we can say that digital twin technology can be used with respect to the economy of data, and it can also be used in terms of collaborations like build, maintain and utilize. So once this system which has been built by an individual, so we can use it or somebody else can use it in our in different industrial IoT system. So I mean to say here that that this digital twin technology can be used to perform the economy of the data as well. They will be can be used to provide integrity, availability, and security of an industrial IoT system, and they can also be scalable with respect to the more data analytics part, and more data can be added into the existing industrial IoT system. Then the most important part is that these digital twins can be used in metaverse, which is one of the core technologies nowadays. So first of all, you can see that metaverse is a virtual reality world where user can interact, they can play online gaming, and they can experience things as they would have been in real world. So these can also be used, digital twin can also be used in metaverse. So you can see at here that metaverse basically is a digital world or reality which is combining basically blockchain technology, which can also use social media, online gaming, virtual reality, augmented and mixed reality, and digital tokens and asset management obviously. So it will helps to fully utilize the virtual space to interact with the another objects in a seamless manner. So you can see uh, these technological features are the basic building blocks why this digital twins can be used for asset transfer or for providing new horizon to the metaverse, where user can check it out or user can feel that they are living in the digital era. And most common components of this metaverse along with the digital twins is that we can use web 3.0. So using the web 3.0 from asset, we will be able to transfer asset in a secure manner on blockchain networks. We can perform NFT, we can use secure gaming in an online manner. So we can use we can have auto AR VR applications. So basically, Web 3.0 is an integral part of modern IoT based applications, and it is the next version of what we call as internet. So it is all about how we can design different DApp applications. Using those DApp applications, we will be able to identify and we will be able to transfer our asset in a secure manner to the public or private blockchain networks, and then using those public or private blockchain networks, we will be able to identify or we will be able to make certain level of predictions using various types of AI based techniques. So digital twins in this regard can be one of the we can say benchmark solutions which can be used to provide various types of solutions. And as a use cases, you can see that blockchain can be used for asset transfers across different verticals, and this asset transfer across different verticals can be done in a peer-to-peer manner. So you can see at here that digital twins and metaverse can be used for NFT. So these NFTs are used for non-fungible tokens, which will be a new way of creation of payment to a person in a real world asset within the metaverse part. So it will allow the user to have full ownership over their assets, and they will make them easier to maintain. So NFT can really be anything digital, such as drawing or music or your brain download, or these can and this can be any tokens. I mean to say that can be transferred and user can have their assets in a seamless manner. So how these NFTs are basically used along with the digital twins in metaverse. So basically, metaverse offers 3D universe for individual and business to help them to transfer real world asset or even services. So this can be help in representing those real world assets. So users or businesses can invest in an NFT, and then these are used to transfer assets between different parties. So they can be used by wide range of users in metaverse, and this can be used in games as well. So where we have the concept of online gamings and offline gamings. So all will get digitalized in the metaverse. So user may be able to play game within the ecosystem, and they will be able to have earn certain level of incentives based upon the online gaming like here. So you can see it here that they can bet on a with different service providers, and within this digital within this digital era they will be able to trace it out the real world assets or value of their asset which has been used in this context. And different digital twins can also be used for cryptocurrency and token management. So these digital tokens and cryptocurrency will be the main source of value within the system. So you can see that platform within the metaverse already offers various types of tokens in this scenario. And we can also have the augmented reality in metaverse. So augmented reality will be enhance the real world with respect to the various sensor elements, sound or imaging part. So it is a real world element that decreases the AR from virtual reality. I think all of you have a very good idea about how this AR VR can also be used along this metaverse applications like virtual realities. Also one of the most common technology that had been used in virtual environment or simulated environment. So it's basically completely separated from the real world entities. So it's simulated experience that can be similar or completely different from the real world. So a user will need a hard mounted devices, and these hard mounted devices provides VR in metaverse such as education, games, fashions, etc. So mixed reality is also can also be used, which can be merged like virtual reality and real world together and create in different environments. So here again, digital and physical objects both exist, and user will be able to interact with the both. So both digital twin copy is also there and physical asset is also there. So user can interact with the both the parts. So that's why here the terminology that has been used is mixed reality that can also be used for the digital twins creation or metaverse creations. Similarly, you can see that there are inherent benefit of using of metaverse. So we can say the experience within the metaverse can open up with new opportunity for individual and businesses. For example, individual can showcase their work or sell their services within the metaverse in full digital form. It's not a physical asset which need to transfer. So they can advertise their product in digital form through the metaverse across different end users, and end user can experience it out the digital copy of the end user product like the physical asset part. So basically it can becomes a place of entertainment, commerce, workplaces, and even social gathering venues where user will only need access to the internet to go to the metaverse. So the metaverse can be the next phase for the internet where every type of digital experience can be in one place, which will make it efficient for the users. So the importance of metaverse stems from its reality to provide a shared environment and economy for all the peoples, regardless of their locations. So industries that are using nowadays metaverse is maybe finance, those can be gaming, fashion, marketing, art galleries, virtual show, architecture part or entertainment part where these metaverse can be used. So how this future of metaverse will look like. So metaverse is still far behind in giving the full experience to the user. Uh, there may be some inherent benefit or maybe there may be some inherent hindrance because you see that 5G and 6G revolution has been the core component of digitalization of physical asset fully to its full potentials, and we need high data transfer rate for different types of application like online gaming, robotic operations, or human computer interaction where we require fraction of seconds to perform various operations. So with the mature of all these 5G or 6G technology in the years to come, so we will be able to have full-fledged metaverse technology where we can visualize the physical asset as well as the digital twin copy of the physical assets. And in this regard, you can see that by 2030, we will be spending more time in analyzing the digital copy of an physical asset in fully metaverse part. And once this 5G or 6G revolution has been there in the rural as well as urban part, so we will be able to have the full-fledged copy of these digital twins as well as metaverse in our day-to-day life applications. So now, till now, you can see that digital twins and metaverse are the future, and which can be used in wide range of applications. And digital twins are acting at basic backbone or building the backbone for real-time applications in metaverse to utilize this fully digital metaverse applications. So a lot of technologies like sensors, machine learning, artificial intelligence based technique, communication and real world data that will go into the digital twin. So it can be mimic physical assets such as things, people and place down to the last details, simulates events and processes, and these will provide insight to provide different types of decision making process. So because it's a virtual copy of the physical assets, so whatever the changes that we peoples are making into it, so those changes can be reflected in the metaverse. And with the maturity of this 5G and 6G revolution across the globe, we will be able to have a fully digitalized world in the years to come. And then it will be all about augmented reality and virtual reality concept where each individual user can check it out their own assets in a digital form, and then they can analyze or performs different types of operations and give their valuable feedback to improve the performance of the digital copy of this asset, and then this can be replicated on the physical asset as well. So this digital twin can empower a metaverse. So you can see, imagine for instance that you are driving with a street map digital twin that exactly depicted a road, its building, traffic and other features in real world scenario, or how authentic it would seems if a digital avatar started to sweat when its human entity was doing the same in hot summer. So these digital twins is not new to the industrial automations. These are uh, being widely used in smart manufacturing since several years to improve the every area of operations. And in the metaverse, the possibility of digital twin technologies becomes bigger and bigger. So you can see automobile companies who are already using digital twins to model car and their performance may launch them in an automobile expo in the metaverse in the not too distant future. So distributed services can also be used here also. So some of the areas for the digital twins technology in the metaverse may be like here. So you can see that this metaverse consisting of AR, VR, human interactions, blockchain, decentralized AI, spatial computing, discovery, virtual and real world interactions. Along with this, the backbone is always, you can see the digital twins infrastructure which has been provided for successful execution of this metaverse across different applications. So obviously, when we have different objects which may be located across different geographical locations, across different layers in this different types of applications. So prime concern is this, how we will be able to transfer, how quickly we will be able to transfer the data between different applications so that we can be able to predict or make certain animation into the digital copy of this product. And obviously this will require efficient uses of machine learning or deep learning based model which will forecast how we will be able to identify and make certain level of transactions at different levels. So this can be one of the potential applications where we can use it out, the digital twin copy of different applications. And then we will have the manufacturing process. You can see the manufacturing industry, we can use different types of I mean to say digital copy of physical assets, which through the revolutions of or applications of AI based or machine learning based technologies, we can optimize different performance evaluation metrics, and with the help of different performance evaluation metrics, we will customize or optimize that particular model, and then we will be able to have the interaction between uh, we will have the interaction with virtual real using the virtual reality. We will be able to have the interaction with the digital assets. So this can be one of the possible revolutions in the years to come, and we can have the interaction both with the physical asset as well as digital assets in the years to come. And obviously in this regard, machine learning, deep learning based technologies and blockchain based solutions can be one of the possible solutions in the years to come. Similarly, you can see one of the use cases here is automotive industry. So you can see digital twins and metaverse integration can help to visualize us the workplace. So they will guide us the correct path, or they will be able to identify different objects. They will be able to identify different lines or different paths, or in this fully customized manner. So you can see at here that the driver in the future will be able to check it out the exact location of pit holes, or they can be able to identify the correct path through which their car is going on, and along with the physical I mean to the digital copy of the physical assets or digital copy of the outside physical world. So it seems that a completely new system where we will have the fully automated system, and we can visualize the surrounding, and then using obviously in this regard various types of machine learning or deep learning based models are already in place, which will guide the driver to take necessary actions, that these are the pitfalls where you have to have apply the brakes or maybe some automated system in the cars, so that they will be able to guide the driver to take left or to right, or there are enormous number of applications. So you will be able to interact with the outside world just like you are sitting at your home. So this can be one of the applications where we can have visualize different components by sitting at a particular instance. And with the revolution of 5G and 6G revolution, this metaverse and these digital twins are supposed to become reality in the years to come, and they can be used in wide range of applications. And similarly, you can have the retail and e-commerce applications are also where we can use the digital twins and metaverse that can allow the people to show up in virtual space where data is updated in real time by the digital twin technology. So that can also be one of the revolutions. And we can have also have smart architectures where developing the construction project, mapping a city areas and managing resources optimally are just a few of the multiple use of digital twins in the metaverse. So here also digital twin can help or build the cities and structure inside the metaverse to help visualize how a city area can be used in an efficient manner, and where we can plant new plants, or where we can construct new buildings. These all can be optimized in a seamless manner with the help of visualization of digital twins and metaverse in a digital city scenario. Similarly, industrial IoT system, you can see there are various types of machinery which are working in different manufacturing systems. So we can customize and optimize the parameter of working of these machines in a seamless manner, which can be used for enhancing the productivity of these machines. So this can also be used with the help of digital twin and metaverse. So this can also be used with the help of industrial IoT revolutions in industry 5.0 revolutions, where different types of devices can be controlled remotely, and their operation can be controlled remotely with the help of smart manufacturing process. So in concluding part, we can say that integration of digital twins and metaverse have the potentials to revolutionize the industry 5.0 in the next generations. They can be used to optimize different types of performance evaluation metrics for prediction, monitoring, tracking, and resource management, optimization, and quality control part. And obviously, implementing the technologies like AR, VR, and other blockchain part, they can deliver even more precise and accurate predictions for different industrial revolution process. And also, we are looking in the future for more connected world where we can have a unified virtual and human computer interactions. And by 2030, we will be spending more time in metaverse than the in real world. So this was the concluding part. So with this conclusion, we can say that digital revolutions or digital twins and metaverse can be used in wide range of applications for smart manufacturing process. So I hope all of you have enjoyed my lecture. So if you have any queries, so I'm happy to answer your query. Thank you very much.
Professor, we have not so much time for questions. And the first question is, of course, from me. Thank you very much. I understand that I will never be unemployed because very interesting future is going. Nevertheless, we know that peak throughput of the 5G network is 100 gigabits. Peak throughput. And what about the concept of digital twins? What will be in future new requirements for the wireless networks? Have you any
Yeah.
thoughts?
Yeah, so in my view, you see that we require strong network infrastructure in terms of 5G and 6G network infrastructure, because we require the interaction between the physical objects and digital objects. Like for example, robotics can be one of the possible solution where digital robots can perform telesurgery operations. So a requirement in terms of I mean to say here, network infrastructure should be there. So 5G and 6G technology can play a pivotal role in implementing in metaverse for and digital twins to be get popularized across the world.
Industrial IoT, it will be enough, I guess.
Yeah.
Thank you very much, Professor. One more question. Professor Gaidamaka, yes. Julia, please, your question.
Dear Professor Kumar, thank you very much for interesting talk on digital twins, a very important part of industry 4.0 to 5.0. And my question concerns perhaps the most attractive problem of our time, the metaverse. It is known, and you have mentioned it in your talk, that the biggest problem in the metaverse is data security. Today, there is a threat that personal parameters of client may get into the public domain. I mean, geospatial telemetry, some technical characteristics of user equipment of client device, network data, including client location, some behavioral features, language, handshake, voice, reaction speed, some cognitive properties. And all this data allows to identify other personal parameters, gender, financial situation, nationality, age, and so on and so on. So, Professor Kumar, what do you think about the metaverse privacy issue? Are you or your
As I have
colleagues,
already
Tapa
told you that
Institute of Engineering and Technology in Patiala, involved in development of any safeguards?
Thank you very much. So you can see that I have already emphasized that metaverse consisting of augmentation of AR, VR, blockchain technology, and it also include machine learning and deep learning based model. So your question is very good. So in this case, we can use blockchain technology for storing the data, and then we can use various types of consensus algorithm which are found to be secure or as compared with the centralized client server based model. So nowadays you can see that most of the times we are talking about the fully decentralized system, and in this regard I would say that blockchain technology can be one of the possible solutions to provide security and privacy for our digital data, to make accurate predictions with respect to the different machine learning based model. As you can see, you have already told that the security and privacy is one of the concern when we have to transfer the data through different digital objects. But if we properly apply blockchain technology, then this data can be made secure. So I hope I'm able to answer your query.
Professor, the last question. The last question. Please, Amar. Yes?
Yes.
Thank you. Your question.
So I'd like, it was very interesting lectures. Thank you for your lecture. Hope to see you offline next time. So as we are from the same field with Professor Konstantin Samuelov and Yule, I have a question also regarding the requirements. So what do you think, what's the main technology in future which can help to implement digital twin? I mean, you mentioned some slides about edge computing. There are another technologies which can help to realize to implement these applications.
Yeah, so one of the technology that can be used for implementation of digital twins is massive MIMO and NOMA, non-orthogonal multiple access, because you can see fast data transfer is one of the concern where we can use massive MIMO, ultra reliable, low latency applications along with NOMA, and obviously channel encoding and channel decoding along with the blockchain technology can be used in mobile edge technology for successful implementation of digital twins in different dimensions.
Thank you. Thank you very much. A few words about the international standardization process in area of digital twins. Only a few words.
So we can use a digital twin in smart manufacturing process, and in the case of industrial IoT revolutions, as far as security implementation is concerned, so we can use a distributed ledger technology for industrialization or standardizations for secure data transfer using digital twins.
So, thank you very much once more. It is a great honor for us to see you at our conference, and I believe that sometime we will meet together physically. Yes, thank you very much once more for your brilliant presentation.
Thank you very much. Thank you. Have a nice day.
And now we are continue. The next presenter is here already. Yes, Professor Dushyant Nalin, please. The floor is yours. You can start and introduce everything yourself as you want. Thank you.
Thank you very much. Is my presentation visible?
Yes, we can see you.
Okay, that's great. So thank you so much for inviting me for this talk. So good afternoon to all of you. My name is Nalin Jayakodi. I'm with Lusofana University of Portugal, and I'll offer this talk with my colleague, Dr. Tarindu Ponni Baduge, and he is with SLTC Research University in Sri Lanka. So today we talk about the age of information, and more precisely, a new performance metric that was introduced to wireless networks. It is about the estimation of the freshness of the data. So during the talk, I will also talk a little bit about the drones assisted network, and it is more related to the self-sustainable drones. Right. So the research efforts for the monitoring research efforts for the low latency networks are, being at a very hot topic, and also the machine-to-machine communication and the tactile internet, and these are requiring delays of just few milliseconds, and that also the key drives behind the 5G wireless network. And when we look at the edge cloud computing, that will also eliminate the transcontinental round trip propagation delay in the order of 40 milliseconds in essential ingredient. So the emerging applications, such as Neeraj also mentioned, the smart factories and the drones, they are increasingly relying on sharing time-sensitive information for monitoring and the control. So it is essential to keep the information fresh. Otherwise, outdated information loses its value that can also lead to the system failure and the safety risk. So the age of information measures the time that elapsed since the generation of the packet that was most recently delivered to the destination. So we can see here some of the ingredient that form part of the real-time monitoring and also control systems. Right. So there are a lot of examples for the real-time services that needs fresh data. When we use the mobile devices or else an application that has made the real-time information updating application more popular, for example, crowdsourcing applications, news feeding, weather forecasting, and also traffic alerts. So the timely information updating also critical for real-time monitoring and control systems. For example, wireless networks and Internet of Things, any embedded system applications. Those are the examples. So the utilization is maximized by sending updates as fast as possible. And however, this strategy will lead to a monitor receiving a delayed updates that were backlogged in the communication system. So the timeliness of the status updates at the receiver can be improved by reducing the update rate. So on the other hand, the throttling the update rate will also lead to a monitor having a unnecessarily updated status information because of the lack of the update. Therefore, timeliness of the status updates has emerged as a new field of network research. So the age of information has been in the computer science for long. However, when it comes to the wireless network, it is quite a new introduction, and that married with the 5G user cases of URLLC and also in the key performance indicators of the 6G. Right. So let's look into the scenario. Why do we need the fresh data? And also let's talk about the conventional delay sensitive, the time sensitive parameters. The first one is the packet delay. The packet delay tracks the time that is largely elapsed from the generation of the packet until its delivery. And the second one is the inter-delivery time, and that is the time between two successive deliveries. So the packet delay and the inter-delivery time would not make inclusive measure to maintain the fresh information at the destination. So the transmission delay and the processing delay, the propagation delay, all need to conclude to have an inclusive performance metric in order to estimate the freshness of the data. So we need to make sure that what we are looking at is the most freshest data. Right. So this is a sawtooth diagram where the more or less the many data freshness metrics are being discussed. So the age of information is an end-to-end metric that can be used to categorize latency in a status updating system. So let's look into this small diagram here. And if you look at an update packet with the timestamp of u has the age t minus u at a time. So here t is greater than u. So to update to be fresh when it is time stamp is the current time t and its age is to be 0. So when the monitor's fresh T1 received update time T has the time stamp of UT. So the age is random process of T, that is, the age of this random process is T minus UT. So these updates are delivered to the destination monitor at the corresponding time of T1 dash and T2 dash. And so the AOI process of the delta T at the destination monitor is reset at the time of T dash J to delta T dash J. So that is equivalent to the difference of the T dash J minus Tj. Or for example, T2 dash minus T2. So the age of the jth update when it is delivered would be the difference of these over the x-axis in the sawtooth diagram here. So the age process delta 1t and the delta t have the characteristics of these sawtooth patterns as we see in this figure. And there is another way of measuring the age of information is more on the probabilistic domain. And however, this is the more linear one and quite easy. Yeah, this is again the sawtooth diagram. It's actually just to make you clear about the delta t. So the delta t is the age of the most recent update seen by the monitor at the input to the network. Because the updates are fresh, delta 1t is reset to 0 at each ti. So in the absence of the new update, the age delta 1t grows at the unit rate. If the source in this figure submits a fresh update as a renewal point process, then the AOI delta 1t is simply the age of the renewal process. So this is the difference between the delay and the age of information. Age of information is a much more inclusive parameter, and AOI or the age of information was shown to be fundamentally a new metric in the literature, and that takes into account the context of the data and the latency and the many other physical characteristics. And two of the most popular design goals in a communication systems that we know are when we're designing a communication system, we want to maximize the system throughput and minimize the end-to-end delay. And for a fixed service rate of an update packet, the optimal rate that the source should generate its update packet in order to minimize the average age of information is different from the optimal rates that will either maximize the throughput or else it will minimize the delay. So maximizing the throughput is quite related to transmitting update packets as fast as possible. However, that results in the update packets become a backlog in the communication system. So when we try to minimize the delay or the equivalently minimizing the system time of each update packet, that can be achieved by reducing the rate of the update generation at the source. So the monitor will unnecessarily have updated status information due to the lack of update packet receptions. So if you look at the well-known performance metric, like the latency, the AOI works quite differently. So AOI also captures the context aspect of the system design. Right, so I will talk about some of our recent research results. This is on the Harvest as you fly. That is an age of information based full duplex drone assisted wirelessly powered network. So, so we know about the full duplex and half duplex. So regardless of the duplex mode, conventional Internet of Things network data freshness at the receiver largely devalued by the delay during the transmission phase. So here you can see that the time block is subdivided. The first part of the time slot that is dedicated for UAV to harvest energy at the sensor control panel. And in the second time slot, that is T1 minus alpha, alpha is less than 1. So we have a parallel transmissions. First, after the energy is harvested at the sensor control panel, the sensor control panel talks to the UAV, and then UAV talks to the access point. So when the simultaneous transmission takes place under the full duplex, UAV introduces interference because it can overhear its own noise. So it will also work against the quality of the experience. Right. So we can see the access point diagram also here. Here we can see the full duplex, TX and the RX receiver and the transmit antennas. Right. So what we did was the average number of retransmissions or the average age of information is inversely proportional to the success probability at the destination. So the average age of information for the sensor node to UAV link is shown in the first equation here. And here R is the rate of transmission, alpha is the time ratio for energy harvesting, and omega h is the average channel gain. And the interference in gamma SU is the self-interference due to the full duplex transmission at the drone. And then we estimate the average age of information for the end-to-end link from the source node to the access point. So what we do here is we multiply, the product of these two, the combination of the AOI between these two links from a sensor control panel to the UAV and UAV to the access point form the entire average age of information for this scheme. So I'm not going into the details. And then what we did was to form an optimization problem in order to minimize the average AOI. We minimize the success probability, and then we solve it from the numerical methods and also analytically. So here are some of our simulation results. So here we study the impact of time ratio and the information rate on the average age of information and the transmitting power and the information rate on the average age of information. So on your left-hand side, the average age of information is a function of the time, that is the alpha that I introduced beginning, that is plotted for a different value of data rates. So the average age of information attain its maximum for a smaller and a larger values of the alpha. For a smaller values of alpha, the sensor has only less time to harvest energy that results in less power to transmit information. And when it comes to the average age of information, due to this, the average age of information will increase. And for a larger value of alpha on the other side, the sensor gets enough time to harvest energy and but less time to transmit information. So when you have a less time to transmit information, which works against the communications perspective, that causes the increase in average age of information. Therefore, it is observed from this figure that the increase in the data rate causes an increase in the average age of information. So this observation makes sense when you are increasing the data rate, that causes an increase in the error probability for a fixed value of alpha. Therefore, rise of the number of retransmission of data packet will cause an increase in the AOI. So let's look into the right-hand figure. Here, the sensor uses energy harvested from the full duplex UAV to transmit the data packet. So the average age of information depends on the energy harvested by the sensor, which also depends on the transmit power of the full duplex drawn during the energy harvesting case. So the dependence of the average age of information on the transmit power of the full duplex UAV is represented in the the x-axis here. So it can be seen from this figure that the average age of information when AOI decreases linearly in the low power region, and it reaches a constant value of 1 at the high power region. So the reason can be mathematically understood by using the polynomial expansion of the average age of information. Right, so I will also present another framework that was, we recently submitted to IEEE transactions on vehicular technology. So in this work, what we did was to use a machine learning technique to understand the age of information that is again based on the UAV assisted network. So when it comes to the practical context, both the data sync and the UAV or the receiver may not have the complete channel state information. And especially during the trajectory of the UAV, that is obtaining channel state information using the pilot signals, that can cause degrade in the AOI performance. Therefore, incorporating machine learning techniques could be leveraged to identify the channel state information from the past experience. So we have used that technique here. So therefore, the dynamically making sort of the decision to improve the performance in terms of AOI can be achieved. Right. Here we can see the system model. Here UAV used as a wireless relay, and that collects information from the sensor node and forward it to the terrestrial base station. We use decode and forward relaying technique in this particular work. And we assume that the time duration of a data packet T, the transmission duration is the T, and the sensor node harvests energy from the UAV at the time alpha T, and they transmit the data packet back to the UAV in the remaining 1 minus alpha T. And we use deep learning based average age of information prediction model here. So we call it a LSTM algorithm that has already been successfully applied for many UAV applications in a different aspect. So therefore, we also employed this to this to improve the solution of the optimization problem that we formed to estimate the average age of information. So I will not go into the math and the algorithms. So I present some of the results here. So we conducted mathematical and the numerical simulation for the half duplex and the full duplex scenarios, in which we considered as actual value and the model estimated values for the AOI. And on this left figure, we can see that. And it was achieved about 90% of the accuracy from the LSTM model. And the accuracy can be further improved by increasing the number of training bits and also size of the training data sets. So as the transmit power of the UAV increases, the energy harvested by the sensor node increases, thereby we reduce the average AOI. However, through the simulation and also from our analytical studies, we found that in the low power region, AOI reduces exponentially and it reaches the minimum value of 1 in the high power region. So the effect of self-interference over the average AOI is also studied in this particular work. And we can see from the simulation results, AOI increases with the increase of the self-interference as well. And we validate the results by using the deep learning model. This long short-term memory LSTM model that validates the results also. So using usage of the deep learning and the machine learning algorithms in the wireless network is still at its infancy. So, it's a largely very developed in the computer science, but when it comes to the wireless, there are a lot of optimization theories and the fundamentals, especially many Russian scientists have been contributed to develop these convex optimization theories, stuff like this. So the the adaptation of ML and DL to wireless network is still taking place at the some bit of the slow phase. So I would now hand over my talk to my colleague, Dr. Tarindu.
Hello, thank you, Professor. So let me share my screen. Okay. Okay, I hope you can see the my screen. Let me, switch off my camera in case connection drops. Yeah. Okay. Can you see my screen?
Yeah.
Yeah. Okay. So, so just to continue what Professor Nalin has said, now I will also explain another two work that we have done in age of information, especially when it comes to wireless powered communication. So the reason why we are mainly focusing on our research team focused on one of the research areas that we focused on is wireless powered communication. As you already know, in fifth generation communication, energy efficiency play a key role. So we are looking at alternative ways of harvesting energy and to have sustainable communication system. So in that direction, we use RF energy harvesting techniques in our communication systems, and we try to identify trade-offs and performance optimizations in wireless communication networks for next future generation of communication system. So as a part of that research, we also started to analyze this age of information because at that time it was newly introduced. And this is one of the work that we have already published. So we have identified that age of information has been not compared or analyzed in terms of SWIFE, that means simultaneous wireless information and power transfer, enabled wireless communication systems. So in order to fulfill that gap, what we have done is we have used the conventional system, wireless powered system model. So where there will be a source and also a destination. You can see in the right-hand side figure. So the source or the access point is powered also by the solar or natural energy that harvested from natural sources. So in the source, we are keeping track of energy buffers and also the data buffer. That means data that we have sensed at the source. So idea is source will transmit that data to a relay node, and the relay node will then transmit to the particular destination that we are planning to send our information to. So in this model, what we have done is we have used the relay node as a wireless power node. So we use SWIFE, simultaneous wireless information and power transfer technique, and then we use both the protocols of SWIFE, that means time switching, and power splitting protocol. So in those two protocol, what we do is the receive information signal, we divide it into different domains in terms of time and power, and the portion of that signal we'll use for harvest energy, and the other portion we use for information processing. So once we harvest the energy, what we are doing is we will use that energy in order to transmit data from relay node to the destination. So in this case, the main idea of our research is to analyze what happens for the age of information performance metrics when we use different protocols of SWIFE. So as you can see in the right-hand side, the evolution, AOI evolution diagram also given. So in this case, you can get a rough idea about how the freshness of the data or the age of the data is changing over the time. So next, what we have done is we have simulated and we have tried to identify performance matrices, average age of information, what will happen in terms of the other system parameters. So first, what we have done is we have checked what is the optimal power ratio and the time ratio that we need to allocate in terms of to have a minimum average age of information possible at the destination. So in this case, we have identified it has to be, if you are using a power splitting protocol, and it has to be around 0.4 ratio. You need to allocate it for energy harvesting and the remaining ratio for information processing. If it is for power splitting, you need to allocate 0.3 and 0.4 portion of the signal for energy harvesting and the remaining power for information processing. And the next simulation, we have tried out what happens actually when we increase the transmission power at the source. It can be maybe it depends on the amount of the power that harvested by the natural sources. So there also we have identified, obviously, when the transmission power increase, the average age of information decrease, and it tend to saturate after some transmission power, if you look at the simulation figure. So from that one, we understand, so for every system performance parameters, there can be a threshold value. So from that threshold value onward, it doesn't matter whether you increase or decrease, it depends on the performance metric, performance value. So average age of information tend to saturate. So if your main focus in your wireless powered communication network is on average age of information, so it is utmost important to identify what are the performance parameters that we need to think of. And then here we illustrate a 3D graph just to get an idea. So which swipe protocols show superior performance. In this simulation, we have identified that power splitting protocol always better if you're focusing on age of information as your top prioritized performance metrics. And time switching also has a similar, but it has less performance in terms of age of information. So keeping that in mind, then we have an understanding about which protocol is better if your main objective is to minimize age of information in your wireless communication. So keep that in your mind. Then we started to work on a wireless power two-way relay network with UAV, and to identify what is the data freshness of this communication system. But as I said to you earlier, age of information or data freshness also act as a one performance metric, but that is not the only performance metric we need to consider, especially when it comes to wireless communication networks. As Professor Navin said earlier, throughput and latency are key points that we need to mainly focus on. So what we have done here is we try to identify the trade-off between age of information and the other performance parameters that we are considering on. So in this system model, we use a two-way relay network. We use a UAV to assist that information transmission between two terminals, and also we incorporate nonlinear energy harvesting circuit in order to make sure that our proposed system model is more towards the practical scenario. And we, of course, we use SWIPE, that means simultaneous wireless information power transfer, power splitting protocol from the previous result. And main idea of this formulation is to minimize age of information. So this optimization has to be done in order to identify the optimal parameters of the system model that we have proposed, which minimize the age of information. And also by doing that, we can get an idea how this age of information having a trade-off with the other performance matrices. So in this communication systems, we focus on outage probability, throughput, along with the age of information. So idea is, if you look at again the system model, so you may be going to travel from a predefined starting point to destination point, and while it is traveling, it will facilitate information transmission between the terminal S1 and the S2. So in this system model, our main objective is to optimize the trajectory of the UAV while making sure the age of information or the data freshness received at the destination nodes are at its best. So that is the main idea. And if you look at the similar works found in the literature, you can see like most of the time they are planning to optimize if we are using more than one performance metric and you are trying to come up with the optimal values or the optimal system parameters in order to make sure that you have the best performance between those two performance matrices. You are doing joint optimization in terms of those two performance matrices. So initially we try to do that. That means we are planning to minimize the age of information and also try to optimize the UAV trajectory as a joint optimization problem, then we have identified that if you are working on trajectory optimization alongside the data freshness, of course you can get a suboptimal values for the performance, for the system parameters, but that will reduce the freedom of UAV trajectory. So in that case, we cannot maximally utilize the freedom of UAV trajectory design when it comes to the minimizing edge of information. So to avoid that, what we have done is we have divided our optimization problem into 3 sub-optimization problems. That means for a given location of the UAV, we will identify the optimal parameters which provide maximum data rates to the destination node. So by doing that, we were able to identify system parameters such as power splitting ratio, transmission power of the UAV, transmission power of the other terminals, etc. So by doing that, we identify what are the optimal values for those parameters, and then we had another a different optimization sub-problem formulated from the main problem, where we are trying to identify the same parameters which minimize the age of information. So out of that, then we can get a combination of which optimal values can be used in order to have a maximum data rate while maintaining and minimize age of information. Next, we formulate a trajectory optimization problem separately, and we incorporate the values that we have obtained from the optimization problem 1 and 2. And as you can see, it is very hard to solve these optimizations numerically. So we design our own 2 algorithms in order to come up with the in order to identify the optimal system parameters required, which minimize the age of information, and also which provide us the best UAV trajectory that can be obtained in order to optimize the age of information. So these are the 2 algorithms that we have designed. So I'm not going to go into the details. So initially what happened is, so you are first focusing on the UAV trajectory. So while you are working on the UAV trajectory, you also consider the UAV constraints also given, like for an example, starting point, endpoint, maximum transmission power of the UAV, and the maximum energy that can be stored in the UAV, and also what is the operational time that UAV has to work on. So all these constraints has been taken into the consideration. Then we then identify what are each and every individual components in terms of X, Y, and the Z direction. That means 3D coordination. We have identified what are the optimal trajectory coordination that we can have from start to endpoint. So for each and every individual point, then we run our algorithm that we propose to identify optimal parameters of the system which minimize the AOR. By doing that, so we would be able to identify what is the optimal UAV trajectory which provide the best freshest data to the destination while having the optimal system parameter selected. So these optimal parameters are not fixed or constant throughout the UAV trajectory. It dynamically change upon UAV trajectory that we have came up from our algorithm. So yeah, so these are a few simulation results. So I have decided to include in this slide just to give you an idea. So what sort of changes and how the performance matrices in terms of age of information can be analyzed. So first figure, if you look at the left-hand side, what we have done is we have checked trade-off between outage probability and the age of information. So as I told you earlier, when you are designing a communication system, there are a lot of performance parameters that you have to think of, and depends on the critical requirements of your application. Some of the performance parameters you should give priority in terms of the other performance matrices. So in this case, just to get an idea, so we have simulated and we have identified when outage probability is minimized, you will get the best possible age of information value. But here we have identified that age cannot be equal to 0. That means definitely there has to be a time that takes to travel your data from generation up to the receiver, successfully receive at the destination. So therefore, depends on your communication system design, so that there is a floor value for age of information. So that means it doesn't matter how hard you improve your system performance or system parameters, maximum that you can achieve is that age of information flow. So this is the flow that will saturate, and this highlighted blue color area is the region where we can practically achieve the data freshness to our proposed communication system. So the other region, that means beyond that region, it is practically it is impossible to achieve the data freshness. So the right hand side, we are just providing a simulation result in order to verify accuracy of our nonlinear energy harvesting module that we have used. If you look at the literature, which are already published, you can identify most of the papers that they have used a linear energy harvesting technique, linear energy harvesting model. In that case, amount of energy that you can harvest from RF signals will be linearly increased with respect to the transmission power of the communication node. But that is not the actual case when it comes to the practical application. So we used an nonlinear energy harvesting model due to the limitation of the circuits or the rectangle that we can implement. There's a saturated value for the power as well. So no matter how hard or how high value that we have transmitted from the source nodes, you cannot exceed the threshold value unless you have done something on the circuit. So since circuit implementation is out of our specialty, so it depends on the results that we have right up to the moment. So we have identified thresholds for the nonlinear energy harvesting model that we have used. So by doing that, we can identify what is the maximum or the optimal transmission power that we can use at the source node. So then it will avoid that, because of that, it going to be avoid usage of additional power at the source, so which is leading to the waste of the energy. And then what we have done is, then we have tried to identify, optimal points that we have generated to our algorithms and also our optimization problem. So these are the three figures. So left-hand side, you can see the optimal, values for outage probability. Then right-hand side, you can see the optimal value for throughput. And also in the bottom, you can find the optimal value for age of information. So of course, we know there's an incestuous relationship or there are dependency between outage and the throughput. And also we have identified it has a direct impact to the age of information as well. So these are the values that we have obtained for our communication model. But if you use another different communication models and run our algorithms, these optimal points may be varied, depends on the parameters or the threshold values that you are using in your communication system. So basically what will happen, so optimal points going to get decreased with the increase of transmission power. So you can achieve the flow. As you can see in the bottom simulation result, your age of information may reach the age of information flow. So that means from that point onwards, it is not going to get dropped. But we are trying to identify what is the minimum age of information that we can achieve in our application. So this is again another few simulations just to verify results. As you can see on the left-hand side, we directly analyze what is the relationship between transmission power and the age of information with respect to the data packet size as well. As you can see again, the age of information tends to go to flow with the increase of the power, but depends on the data packet size also play a significant role when it comes to the age of information. On the right-hand side, you can see how outage probability and age of information again works with different sizes of data packets. But obviously, by looking at the simulation results, you can understand when it comes to the low data packets, that means data packets with low number of bits always tend to have a best age of information value. That means the freshness as possible. But this is, we need to also think about, like, we are not only sending a small chunk of bits. Sometimes if you are sending entire data vector and you are dividing that entire data vector into multiple small data packets, but sometimes the combination of age of information can be higher than sending a larger data packet. Now, for an example, if you think like you have a data that you need to transmit the size of 256 bits. So it is now from the results you have identified that once you minimize the number of bits that you use for a single data packet and you transfer. So for individual data packet, you can achieve best age of information. But now in your case, if you, by analyzing, getting that summary into your mind, and if you're trying to divide your 256 bits into small chunks and send, but the entire data vector, if you look at as a whole, so the average age of information to receive the entire data vector sometimes can be higher compared to the larger data packet if you send the entire vector as a one data packet into the destination. So it is very crucial in order to identify what is the exact age of information that you are planning to achieve. and also how your data has to be sent, and what is the combination of data means to the receiver or the destination node or the application that you are considering for your communication network. And this one is the UAV trajectory that we have come up with. So as you can see, UAV always tends to go closer towards the terminal when it is receiving data from the terminal, and it try to change its trajectory to go towards the next terminal when it is trying to transmit the data or receive from the terminal S1 to S2. But if you are now doing this trajectory optimization as a joint optimization problem, as I told you earlier, so your trajectory always tends to go closer to the direct trajectory, which is not the best suitable optimal trajectory that we can come up with. So that's why the reason we have divided our entire optimization problem into 3 sub optimization problems and solve it. Because of that, we have now a fully freedom of our UAV trajectory. So by incorporating that, we were able to achieve the best result for age of information. And at the same time, you can see again the UAV trajectory depends on the data packet size that we are trying to transmit. If you are trying to transmit less data bits in a single packet, your trajectory somewhat comes closer to the direct trajectory between start and the destination node. When the data packet size get increased, so it tends to fly towards these terminals in order to make sure that UAV has a direct line of sight connectivity to the destination and will have a good performance at the destination. Okay, so now I will just simply a little bit talk about the importance of AI. And now, when you think about an AOI, we need to think about it as a random process, and also we need to think about how AOI can be used when you are oriented on random access in the next generation communication. So Ericsson predicted in 2021, I mean last year, that there will be around more than 28 billion IoT devices. Similarly, Huawei also predicted, because of the evolve of IoT applications and also increase of smart devices. Now, devices connect to their networks now has significantly increased up to date, and also it will increase more in the future as well. So that means, and most of the application also in next generation communication, you can see they are more tends toward the real-time application. If you think about application like intelligent transportation systems, or special cases of IoT application, for example, Internet of Skills, tactile internet. So those emerging technologies always tend to go towards having real-time application. That means the data that you are going to transmit in those applications will have a higher value if the freshness of the data is increased. So for an example, if you give a point for each and every individual data that you are receiving at the destination, so it depends on the freshness value. So the value of your data packet will get increased. So that is the idea. And initially, so centralized scheduling now not going to work. So you need to decentralize the scheduling. So by doing that, then you can improve the data freshness as well. So the main problem, or the problem that we need to tackle in future, is how to schedule the status updates of massive IoT devices to achieve low network-wide AOI. So this is one of the area that we need to tackle in the future. Researchers also planning to tackle this one in different direction. So this is in general, this is the problem that we need to solve in the future in order to facilitate this massive number of IoT devices in our communication networks. And also it is very important to understand, so when you look at IoT applications, so the data that you are transmitting between communication nodes sometimes maybe not that large. It basically you are sending values like temperature, so sensor related data. So in that case, edge of information can be easily optimized because the amount of data that you're transmitting is a little bit comparatively low compared to the data that you're transmitting, for an example, high graphic files or videos. So now this age of information, now theoretical aspects we have explained a little bit, and also we have explained a few simulations we have done. Now you get an idea how this age of information performance metric has to be worked on your communication network. Now, how about applying this one into your practical application? So everyone, as you know, now 5G is in implementation phase. Now researchers are working towards 6G, and there are a lot of topics now emerging in the 6G as well. But I don't think that we need to understand. So for 5G, with respect to the 4G, you need to change the infrastructure significantly. But in the 6G, if you are trying to do the same, it will introduce you a massive lag. That means in deploying your 6G. So as a researchers now, most of the researchers planning to come up with technologies or algorithms that can be run on top of 5G infrastructures. But the the problem is, so you need to work on interoperability between the 5G infrastructure and the technologies that you are performing into 6G. So that will play a major role in next generation communication. And age of information implementation also getting a little bit complicated because of that reason. And emerging application also will increase, rely on share time sensitive information for monitoring and control, as I said earlier. So if I say a specific example, you can think of monitoring mobile ground robots in automated fulfillment warehouses at Amazon and Alibaba, like massive retailers. You can see they are using these technologies right now. And also there are collision prevention application for vehicles on the road, especially for intelligent transportation system. So if you go to the Huawei websites or Huawei intelligent transportation system, so you can see the intelligent transportation system that they have implemented and also proposed with the technical details as well. And also you can use it, path planning, localization, motion control for multi-robot formation. It can be either used in drones or ground robots. One of the practical application you can see in the next Qatar 2022 Football World Cup. So we are planning to use drones to provide ad hoc communication to the crowd, and multi-drone system for tracking mobile spectrum cheaters. So that is also very much important, especially when it comes to 5G. So as you can see in this all application, time-sensitive information plays a crucial role to provide a better service to the destination node. So in this application domains, it is essential to keep information fresh as possible. And if you have the outdated information, you need to get rid of, and you need to increase the freshness of the data, so you will receive the more freshest data at your destination in order to take the decision. So one thing we need to remember is, especially this in real-time, time-sensitive systems, the next operation or the next process critically depends on the information that we are receiving from maybe sensors or other communication nodes. So it is very important to have fresh data at the destination in order to get the best possible and accurate, so next process in order to be taken out of this application. And if you are failing to do so, what will happen? The process that you are doing at the next, so will make your entire application into a catastrophic disaster or maybe an entire system failure. So if you, for an example, if you look at an intelligent transportation system, so if you are not getting freshest information from the vehicles using V2V communication or any other communications available, so what will happen is you cannot get real-time decision making because you don't have the fresh information. You have the outdated information. So whatever the decision you are taking out from your application will leads to more safety risk. And another key thing that we need to highlight, and if you look at the time-sensitive application right up the movement, all are implemented using IEEE 802.11 standard. That means Wi-Fi, which is not, quite suitable for when it comes to data freshness. So this IEEE standards has to be, updated in order to focus more on edge of information in different layers of communication networks, including MAC layer, physical layer, and also the network layer. And so in addition to that, if you look at the various practical implementation that you can see, so small-scale underloaded Wi-Fi networks are capable of supporting time-sensitive application up to a certain threshold, but it will not enough to support the communication requirements that we are going to have in our next generation communication, including the proper 5G as well. So if I categorize what are the two main shortcomes of Wi-Fi in terms of age of information. That means they are most of the time using first come first serve rate are the queues, and which is not suitable for this kind of application. So this queuing policy has to be decided, depends on the requirement of the application. So there are a lot of queuing methods or technologies available. So we need to think about, we need to create a mechanism in order to calculate this age of information at the queues first, and just to get an idea, so which queue structure or the technique that we need to use in order to maximize the data freshness within the queue. Because as I told you earlier, and also Professor Nalin told you, like age of information is not round trip delay. So it incorporates a lot of processes. So if you look at one data that it is generated from a source node, and once it is received at the destination, there are a lot of processes going on within that entire communication period. For an example, there is a data generation probability at the source. So once it is generated, it will be put into the data buffer. That means a queue. So the place where you are going to wait until you are transmitted to the receiver. So you need to think about the time that it allocates over there. And then once it is transmitted, you need to think about whether it is cooperative communication or any other communication mechanisms that you are using. So that time also need to be taken into the consideration. Then, and also if you look at the destination node, you have a predefined quality of service, threshold. So that threshold has to be achieved. If the received signal is below that threshold value, you need to retransmit your signals. So if you're retransmitting means, again, the time it is spent time. So that also has to be taken into the consideration of age of information, analytical expressions or the age of information calculations. So likewise, it is quite a complicated process where you have to combine all of the, small microprocessors that are involved in transmitting data from one end to another end. So the queue we need to select accordingly, and also the access mechanism and as well. So that is the main shortcoming of Wi-Fi. And so it has to investigate a little bit more, and different version of Wi-Fi can be introduced in the community. So where these concerns are met. And now I will conclude, and I will also give you some future direction in towards this age of information topic. So AOI recently emerged, but AOI is in computer science field for a lot of, nearly more than a decade. So where they mainly focus about the queue policies, but now it has come to wireless communication as well. So as you know, now it's not like in the past. So past we are specializing in one technical field, and we trying to implement things in that specific field, but that is no longer going to work in the next generation communication, because now next generation communication, you need to think and you need to visualize process as an application where you need to work in an interdisciplinary research in order to have a proper application built. So age of information now has moved towards the wireless communication. Now people are working on how this age of information can be characterized in wireless communication now, and how it can be used in real-time application in for future. And also this introduction of information freshness requirement will create system that works smarter than harder. The reason is you will have access to the freshest data that you can have. So because of that, the decision that you are making in your application will be more effective and more efficient, and it will give you the best results in terms of the context. Either it can be intelligent transportation systems, it can be an application in industry 4.0 or in future 5.0, so on. And also, I mean, in terms of that, you need to also keep on mind this updating process. That means getting freshest update from the sources should not, underload or not overload the system. So you need to make sure that the primary, performance metric has to be there, and you are not going to give any I would say, like, you are not going to degrade the performance metric, because you need to always make sure that the primary performance metric has to be equal or more than the threshold value that you are defined for the application. And so at the same time, then you need to think of incorporating this age of information into your application. So you need to make sure that it will not give additional burden to your entire communication system. The reason is, as you can see, so the age of information also we can use our own algorithms and so on. So even to solve the optimization problem, it will take some computational resources and also time. So we need to make sure that those time and the complexity of those executions are not, will not overload the system, and also it will not degrade the performance. And also we need to have a mechanism that system always process new updates rather than old. That means if you are not receiving the freshest update, you are not going to use the old updates that you are having, have access to. So instead of that, what you are doing is you will use somehow you will improve the process, so you will have access to the freshest update that you have. Because if you have taken a decision from all the data that you are having at the moment, entire your application will be not effective as we think. And also, system should avoid processing updates without sufficient novelty. So when you are processing these updates, or when you are trying to increase the freshness of this information, so you need to think about a novelty which is more unique to your context or the application. So as I told you, maybe algorithm or one process that you are using for this age of information into one particular application is not going to work into another application. So it has to have its own unique features and also novelty when it comes to the application. And still, now, if you look at the literature up to now, there has been many work on age of information, but still there are a lot of new interesting research direction towards this age of information. And for example, there has to be a mechanism to identify definition of effective age, or the value of information, which is also a branch in age of information. So value of information definition comes in different aspects. If you can see the right hand side figure. So this value of information comes from by considering internal cost, external cost, consumers, and probabilistic factors. So decisions that you're going to take, and also system, that means the system capabilities. So system threshold. So you need to make sure that by incorporating this new performance metric into your system will not get overloaded, or maybe your system will not degrade the performance that it has in the future, past. So future, you need to make sure that your system is stable. And also sampling and remote construction and deploying of AOI in machine learning. So as you can see now, machine learning comes to the play in wireless communication network. So AOI also a good path where we can think of how machine learning can be incorporated. But when you are incorporating these external technologies into AOI, you need to make sure that you are paying extra attention towards execution complexity of those technologies, and also time complexity of those technologies, because it will also have a direct impact to your freshness, data freshness at the destination. And also, age of information provides strong connection with the areas like signal processing, because it also can be again used as a metric that can capture requirement of wireless network control systems. And also AOI is one of the dimensions of semantic empowered communication. Because if you look at this, if you are familiar with semantic web in computer science, so that's how your search queries and everything works. It incorporates different technologies like natural language processing and so on. So AOI also kind of we can think of as the same, and we can think like semantically how this age of information can be incorporated into the wireless communication systems. And also you can think an entire communication network as a complex network where multiple nodes have different sort of interactions between each and every individual node in the entire communication network. So you can think of like an behavioral impact of these complex networks, and you can try to identify maybe a bridge, or maybe you can identify a relationship between data freshness and the characteristic of complex networks you can find in the nature, and how it can be adapted to the wireless communication networks as well. So these are a little bit few future direction, but there are massive future direction. Even analytical wise, still you need, there's no fixed analytical model for age of information, and that characterization also has to be done in future. So these are the reference that we use. So from that, I will conclude the session. And if you have any questions, I'm happy to answer. So thank you very much.
Professor Nalim and Professor Pereira. We have at least a couple of minutes till the coffee break. Nevertheless, we have time for, of course, ladies. The first, Professor Gaidamaka will.
Dear Professor Yayakodi, thank you and Dr. Pereira for the very interesting talk about Age of Information. And my question is about polling disciplines. What do you think about the idea of polling sensors, sources, not in accordance with first come, first served disciplines or according to random multiple access mechanism, but according to some other principle. For example, taking into account the quality of radio channel between a sensor and a drone. Maybe, I mean, the current transmission rate. Maybe some proportional fairness or maybe anything else. What do you think about this idea?
Yeah, I mean, that is the exact way that we have to think when we are incorporating age of information. So just to begin with, in this keynote, we have only included, data rates and a couple of performance matrices. But as you correctly said, it depends on the application that you are targeting on. As I told you earlier, I mean, age of information, we cannot give, we cannot give a critical priority only to age of information. If you look at communication networks, it doesn't matter whether you have access to the freshest data, but also you need to make sure that that data is accurate, and also that data is there is minimum error possible. The data that you received at the receiver, and also when you are taking decision, you need to make sure that the performance quality of the data has to be there. So that's why it depends on the application. When you think about the freshness of the received data, you can always think about the other performance matrices. But the problem is, so age of information, still we are studying as a separate entity. So we need to think about the age of information with the other characteristics that you have said right now. And we need to identify the relationship. Either, it can be done in mathematically or maybe simulation wise. But mathematically, it is quite a bit of challenge because we don't have proper probabilistic models for age of information. So that is also a fruitful future direction when it comes to this wireless communication. So we hope, researchers maybe will build something, or maybe PhD students. So they will come up with some sort of probabilistic model for age of information. Then if you have access to that probabilistic model, then what we can do is we can think about all other performance parameters and see how these two models interact. So then we identify the trade-off. And it is very important that you define the threshold for your application. So that's why I told you earlier. So having a one model will not work in different application in next generation communication. It depends on the types of sensors that you're using, types of information that you're transmitting from one location to another location, and also the general requirement of your application. Yeah.
Thank you, Dr. Pereira. I believe that, of course, we have not so much time for physical communications, yes, especially maybe today at the welcome party to minimize the age of information between us. So we discuss very modern problems. I understand them, especially from the point of view, because these days, this autumn in my team, we are starting, let's say, not project, but discussions regarding the formalization of problem in mathematical terms, in terms of queuing theory. And maybe, I do hope maybe Amar will help us to have some seminar to discuss more closely this very interesting information lately. Yes.
Yeah.
And just
So
now,
if you also,
yes. So
you
I
can also contact
our seminars, and maybe in October, when you will have time slot, we can discuss this very interesting thing for us, and maybe our students will find good problems for communications between us. So thank you very much for your brilliant presentation. Yes, we are waiting you in Moscow, of course. And thank you very much.
Yeah, thank you very much, everyone. So have a nice day.
And bye. Bye. Yes. Так, сейчас кофе, now coffee break, half an hour. And please remember that throughput of elevator is very restricted. We should go downstairs to the third floor and come back in 30 minutes. Please coffee break. And so we continue our plenary talk session, and we have two talks. The first talk will be made by Amar Muhtana from Boyce University of Telecommunications, St. Petersburg, and he's simultaneously have half position here in Budny University. He director of the research center. Amar, you can introduce yourself, and please, after your presentation, I ask you to moderate my presentation.
Okay, thank you.
You know the schedule. We promise you not be so long. Yes?
Yes, well,
You have 40 minutes.
thank you. Yeah, I think microphone is now. Hello, dear colleagues. It's my pleasure to present, to participate in this conference as keynote speaker. This about Professor Pamelov introduced me. That thank you very much. So I am working in St. Petersburg State University of Telecommunications, Punch Bridge, and part-time I'm working here in Rudin University. So Rudin is my home university as well. Today I'd like to present towards 6G enabled reliable low latency. First, I will try to give some few words about our experience, some about work with our team, and some after that I tried to search some recommendations from different papers, white papers, and standardizations, international standardization organizations for this field. After that, I will try to discuss short solutions to support. Sorry, it's like this. So the agenda of this presentation: first, roadmap to 2030, some architecture aspects for 6G networks, networking and connectivity features, some KPIs, and after that about URLC applications, some examples, use cases, and so on. And at the end, new technologies to support URLC applications, and some direction for research challenge for future research. So first of all, some words about the hands-on experience. We are working with many technologies. We started work with Internet of Things devices from 2012, starting from the modules, ESP, LoRa modules, and so on, and until the core network and the solution of the core networks. Here we have professionals in this field, the core network, in some emulations for the core network. Dr. Abdulkader is working in this field. And also in the core network, like there are many of software solutions like NFV, software-defined networking, slicing, and this is some of equipments and some open source solutions which we are used. For example, on a platform which consists from the software-defined networking, orchestrations, and edge computing, and so on. It's one of solutions for service migrations or for future NFV technology. And also the end applications like tactile internet and drones, ultra low reliable latency applications. We are working now with holograms We have some kind of applications. We are trying to real-time solutions for holograms, for holographic solutions, and also for robot avatars and all these applications. No, as well AR, VR, and all these applications. So about model network, I don't have to go in details because I think a lot of you are familiar with it. About our activities, we have we organize host for ITU, artificial intelligence machine learning for 5G networks for 2 years. This year we could not organize these due to the situations last time. So we organized 2 hosts here in Russia with colleagues Artem Volkov, Abdulkadir, and this was many participants from all the world, and the winners was finalized in they get good prize from ITU. In first year was from Ufa University, second from Iran, the winners. So, and we have some activities in focus group autonomous networks. This is new focus group, some solutions about using artificial intelligence in future 5G networks. And we have some contributions in this focus group in the technical specifications, use cases for autonomous networks. Yeah, this is with Professor Kucherian. So about main research directions, so we are working with the 5G networks, UAV, AR/VR holograms, and URLC applications. And for all of these, there are new terms, software network. I will discuss about this later. So this software networks consists of the software-defined networking, network function virtualizations, edge computing, slicing, service migrations, and all these directions. So about the historical and estimated evolution for 6G networks. So as we know, for first generation, the main aim for us is voice calling. After that, the requirements for in 2G, 3G is to send SMS, internet. So the requirements is to be good bitrate and with good quality of service. That's why the change for the network is to support different applications, different services in the network. So after that, in 4G, we have Internet of Applications, Internet of Things, massive broadband, and Internet of Things in 5G networks with ultra high dense network. And in 6G, we have new applications like ultra reliable latency applications, which need more quality of service, new seamless networks, new spectrum, and some new technologies, solutions to solve this. This is what we are going to talk in this presentation. So the 6G networks, architectures, and technology are still open research. There are no recommendations. That's why first, in this talk, I am going to present summary of some 6G trends related networks and connectivity to, and to compare different white papers, standardizations, and after that, about URLC applications. So why 6G? Today's 5G is strong technology. Intensivity developments, however, it is limitations, and it needs for more it needs more technologies, more solutions to support different kind of services. Six efficiency for 2030. The society will be data-driven, served by near instant, unlimited wireless connectivity. So the 6G goals is meet novel network demands. For example, ultra-high reliability, high capacity, efficiency, low latency in holistic vision. Answer needs of economic, social, technology environments for 2030 areas. Integration of the space, we have, for example, UAV drones, terrestrial and maritime communication. This is the main points for 6G networks is to integrate all these three together. I mean, sea, air, and ground, and to do more connectivity for the future networks. So the large range of applications and services, for example, AR, VR, holographic telepresence, telepresentations, e-health, as Professor Niraj mentioned before, also about twins, digital twins, and all these applications, Industry 4.0, and robotics, unmanned mobility, new devices replacing smartphones. So the second is telepresence, high resolution imaging and sensing. This is like 3D mobile robots, drones, distributed artificial intelligence, haptic communications, and so on. The third also autonomous connected vehicles. It's also one of the key applications for the URLC applications, wearable displays, mobile robots and drones. The human-centric new Internet of Things, nano Internet of Things, mobile broadband, low latency communications. So what candidate architecture and technology for physical layer and for third layer like protocols and so on is still open. Research issues. So I search for about recommendations and organizations in ITU. There are new focus group for network 2030 technology on networks. In this focus group, there are many solutions for the future 2030 networks. There are still no terms like INT 2020 for 6G networks. Only network 2030. So here the main points for 2030 architectures is heterogeneity, native slicing, programmability, simplicity, and network determination, and so on. So in 3GPP, here the standardization, the key technology trends for the short, medium, and longer term solutions for the 6G networks. And this is the evolution in 3GPP for these technologies about number of antennas, frequency, technology goals, and so on. Here, the 6G architecture in the aspects, there are enabling technology. Here, two groups like innovative network architecture and intelligence in the network. For example, multi-connectivity and seamless architecture. seamless mobility and integration, or the potential of this is seamless mobility and integration of different kind of links. And the challenge is scheduling needs for new network design. And the main use cases for this is preference connectivity, on-net mobility, holographic telepresence, e-health. And for 3D network architecture, the potential is ubiquitous 3D coverage, seamless service. The main challenge is modeling topology optimizations and energy efficiency. The use case is previous connectivity, e-health, on-net mobility. And for others also, I tried to, from this is the source, the survey paper towards 6G networks use case in IEEE Communication Magazine. And here the another enabling technology and their potential challenge and use cases. About integrated space aerial, terrestrial, and undersea networks. This is, I see, the main important area for the future 6G networks is to have full connectivity for all the airspace and undersea networks, because underwater networks, undersea networks is also a very important topic for future. I think this is will become a very hot topic. And as we see, there are for the UIV, Professor Nalin had a good presentation. They have very good solutions and experience in this field. So I am trying to the levels of the UIV for full connectivity is space network, air network, terrestrial network, and undersea network. In the space network is like LEO, GEOS, satellites, and so on. In aerial network is like hubs, UIV, and terrestrial. We have the pasta stations and so on. And in underwater also there are like undersea sensors. Maybe maritime autonomous ships, autonomous marines, and so on. This is unmanned aerial for unmanned aerial vehicles, and also in second, we have, for example, an example like how to use mobile bus stations. So the novel 6G networking technologies is here I summarize like nano networking, bio networking, and optical networking 3D networks. In nano, we have nano Internet of Things. Is based on molecular communication. Different materials such as graphic and metamaterials can be used to build nanometer range devices. Physical design for molecular communications is a challenge task also. Here we have also famous professors in this field. Professor Dmitry Molchanov and Konstantin Evgenievich has a good work in this field. And bio networking using biological cells are used for communication using Internet of Things. Novel routing schemes to be developing for bio Internet of Things and non-Internet of Things compared with traditional Internet of Things. And efficient nano devices and bio devices must be developed for nano Internet of Things and bio Internet of Things. And for 3D network, drone-based user devices and drone-based stations to enable communication networks, and novel modeling, including like routing, must be devised for 3D network. So here comparison between 6G and 5G in terms of frequency, latency, mobility, spectral efficiency, peak data rate, and no, I think it's familiar for you also. So about KPI for some use cases, here you can see here you can see the use. Some use cases like experience sharing, for example, AR, VR, augmented and virtual reality, telepresence, and the main also requirements is like network management, latency, and reliability and capacity for this technology. Remote control, for example, e-health, industrial 4.0, and mobility, and connecting everything. So here you can see the requirements is for latency is to be less than 1 millisecond, and also for the data rates as well. So for example, for armored mobility is very important is vehicle speed. For this spectrum efficiency and energy efficiency for pervasive connectivity. So this is the link also if you are interested from the same use case and technology towards 6G. It's very interesting work also. This is also continue to compare 5G and 6G KPI. Also based on the white papers was analyzed. For example, peak data rate, experience data rate, peak spectrum, area efficiency, energy, latency, reliability, jitter, and mobility. So about the main topic is the URLC, ultra reliable low latency applications. Here we have also survey paper in MTBI journals where we delete this into the 3 main groups of URLC. The first group including URLC applications that require end-to-end latency of 5 milliseconds or higher. For example, augmented virtual reality and mixed reality. The second group is URLC applications that require an end-to-end latency of 1 millisecond, for example, tactile internet. And the third group is conscious the sub-millisecond applications, for example, holographic communications. So this here also the URLC applications, the smart factories, intelligence transportation system, robots and remote control, virtual reality, augmented reality, healthcare, smart grid, and tactile internet. For smart factories, the use of devices and precision and control in area, time for repeat production and facilitating process in factories. Intelligence transportation system is autonomous driving traffic. It requires scalable infrastructure, high reliable communications with very low latency, and special stations to achieve the route CBT. About the robots and remote control, as an example of robots and remote control, the remote surgical operations in places affected by natural and industrial distance. protects the human elements in the shortest possible time. The VR, many applications requires very high data processing and accuracy, such as remote surgery, need VR technology. AR technology has made it wide into several applications, including distance education, medical services, gaming, smart cities, and running pairs without human leases. And healthcare, this includes remote surgery, remote diagnosis, and performance diagnosis operation using human-assisted robot systems. About smart grid, we have important requirements in terms of reliability and latency. So it requires very low latency keep pace with the requirements and applications in which the smart grid use. And tactile internet is also the fourth wave of the traditional Internet of Things, internet that enabled the transfer human scenes in real time. So there are many new technologies for URLC applications. For example, animated aerial vehicles for UAV for URLC, software-defined networking, network function virtualization, D2D communication, distributed edge computing, service migration, artificial intelligence. I will show some of our work in this area. So about benefits of deploying fog computing for URLC application is for low latency, for real-time interactions, bandwidth, low energy consumptions, mobility, and spectrum privacy. The benefits for edge computing are also the network congestion. So we can classification do for traffic, data uploading, security, flexibility, availability, latency, and so on. So in details about edge computing, I think all of you know the location of the edge computing. What's the benefits is the computing will be close to the users, and that's why the latency will be so we have also this very old our work in multi-level edge computing. We still continue this work also based on this multi-level edge computing. We are using now, for example, distributed artificial intelligence, distributed microservice migration for this architecture as extended work for this architecture, which was developed in 2019 here. About unmanned aerial vehicles and the benefits for URLC applications, the industrial for the industrial Internet of Things, UAV can be used to increase production, monitor industrial areas, and control production processes in the dangerous places. Internet of Things-based industrial systems, for example, Industry 4.0, can use UAV to support the communication network by providing the required coverage and latency. And for AR/VR, deploying UAV for AR/VR systems, users can see real video from high with very good quality. The use of UAV in the market helped virtual reality technology in the purchase decisions processes by offering the best products to the buyer. And real-time monitoring UAV also used monitor route traffic, regulate traffic, and reduce route density by sending direction control and traffic lights by collecting route traffic. Also, UAV are used in monitoring railways and highways to facilitate route management and achieve high level of safety. And lifestyle application, also UAV can be used as air station to receive. So the main applications of UAV can be used as 5G use cases to assist communication in 5G, 6G. Here, UAV as 5G use case, it can be for millimetry applications, for civil applications can be used. UAV can be used also to provide coverage energy and computing resources with things deploying, for example, Internet of Things networks, as also we was in the Nalin's presentations works. And to assist low latency applications, UAV are used to provide energy and computing resources to ultra low latency applications, for example, AR, VR applications. So the main challenge with UAV is energy security, resource allocations, and first standard design, traffic handling, prices control and routing. How to use artificial intelligence empowers UAV for assist the flight, for aerial intelligence, for assist UAV applications, and for assist the target applications. So, for example, flight design, flight control, environment, and object recognition. For aerial intelligence, collision, routing, swarm, communications, self-maintenance of technology and routing, and for target is resource allocations, optimize wireless charging, traffic prediction, and so on. So we have also many works in this, in routing protocols and multi-level and edge computing to use to use UAV as moving edge computing to help with this. About artificial intelligence, also it's one of important technologies for the future networks. We use this for prediction, for latency prediction, and for example, for robots, we can predict the latency and so on. And also for hard mathematics problems, we can use this for optimizations. The communication also, this is one of our old works, but it's still now novel and can be used for the solutions for high-density networks. Here, we suggest in this work multi-level edge computing. So edge computing can be in micro, mini cloud, and min cloud, and also can be used cloudlet. This is the fourth level of edge computing, where we can use the mobile terminal, maybe laptop, as the edge computing for any other applications like augmented reality, virtual reality, and so on. So in this also we can use the distributed artificial intelligence as one of our future works. Software-defined networking, I don't have to go in details. Also, we have this work about service migration. We have, as I mentioned before, this is term software as network, softwareization network. This is in ITU, and this from focus group IMT 2020 is 5G, and these terms include edge computing, edge computing, software-defined networking, slicing, and so on. In this area, it's also very open area for research. We have also many works with colleagues about what is microservice and what is microservice live migration. You can see the definition. This is from ITU. Is to migrate the service close to the users. So this is an example. For example, some of services we can migrate close to the users in case of, for example, many users or maybe some kind of game or, for example, football or something where many people using some the same service. Then we can migrate the service. We can use another sources and migrate the services close to them to help with, for example, solve problem with load, with latency, and so on. So this is one of architectures which was proposed by one of our PhD students. An example is also observed photo, which used by Google Photos. Here we can migrate the service of artificial intelligence. So now we are trying to work on system like Octopus. So what's this? The intelligence of Octopus is that the nerve is distributed. So the very small of nerves are in the head and others are distributed on the arms of the Octopus. That's why we use this system for like 6G architectures to solve problems with distributed edge computing. So we can use these view algorithms to distribute it, for example, edge computing for many applications. No, as I mentioned before, the IR, machine-to-machine, D2D, internet, autonomous vehicles, Internet of Things, and so on, to solve problems with the latency and to also. Here, a lot of tasks are still open for research. We are working now on this field, this kind of architectures for the future. Here, I summarize some kind of research challenge for these networks. So in conclusion, I'd like to see that URLC communication are main applications to run 6G systems. And to solve this problem, I try to suggest to explain some technologies and some of solutions which we already used. We are planning to extend for these kind of applications. So thank you.
So what about questions? Professor, please. Question.
Thank you, Professor Amar, for a very interesting talk. And I see that you mentioned that one of the key technologies that should be used for 6G is network slicing. And what, from your opinion, is the difference between the network slicing, what was considered for fifth networks, fifth generation network, and what are some additional features that will be specific for 6G network slicing?
So, as I mentioned, there are no recommendations and standardization how the architecture of 6G is will be look like. So there are many white papers where they use the same technologies, which was for 5G, but extended for the 6G networks. I think there are no difference, but this, for example, in case of project Abdulkader platform with surface migration also can be used slicing in this case. So yeah, it will be extended.
Thank you.
No different.
Thank you so much.
Professor Muthana, one more question,
Oh.
if we have time. Yes, I have the microphone. Dear Professor, we know that even for 5 generation networks, the requirements for delay are very strict. 1 millisecond, not for end-to-end delay, but for round-trip delay. And what do you think about the possibility of reaching this latency limit? What do we need? Some disruptive technology or something else? What do you think?
No, I think it's not only the core network, but we need also in physical layer many solutions. For example, I see you have also active team here with multi-channel fusing with terahertz and all in physical layer with the new radio and all this in not only in core network, but also in the radio part also we need to reach this into millisecond latency. So I mean, the core network, like using the mentioned technologies and also in physical layer.
Thank you. Thank you.
So we have the last presentation. The first part of this presentation I made when I was in Tomsk State University, and the presentation is it okay? Okay, is it okay? So my presentation devoted actually to the presentation of 2 books, which was written in Ruden by our team during last year. The first one was published in Springer Nature, maybe in December 2021, and the second one was published 2 months ago in Russian in our university, and I will give you some comments about these books. Of course, to write these books, it's very hard work. It takes sometimes 1 year, 2 years, several years. Yes, and in book, I say to my pupils, we are trying to describe our life in words. It's the same dissertation, but those parts of my life which I spent in research, together with my colleagues. So the first, that is, I will show you the first part of the presentation. I remember that Professor Moiseyeva knows this part, that is regarding the book published in Springer Nature. Professor Udo Krieger, well-known professor, our friend, and very good expert in mathematical analysis of performance of telecommunications in stochastics process and so on. He wrote the foreword to the book, and he wrote very interesting thing. I appeal to our students, first of all, of course, that you should remember the very initial point where your science has been started. And here you can see a number of names, maybe not of all names, which are we usually write in Russian books. Nevertheless, we can see at least 20 outstanding, he says, Udo Krieger says, giants on which shoulders we are standing and going forward in the queuing theory, in stochastic process, and especially in applications to the telecommunications systems. So that was our preface to the book. I'm very grateful in this book to Valery Naumov, my friend Yulia Guidamaka, Natalia Yarkina. Yulia and Natalia are my pupils, and they thank you very much for your great efforts, which we paid, let's say, paid to while preparing this book. And this book we devoted to the applications of the queuing theory in analysis of modern telecommunications. During last maybe one or a little bit more, we and our, of course, colleagues all over the world introduced a new class, let's say, of queuing systems. We called them resource loss systems. That is the multi-service systems with random resource requirements. This, what is the problem? Of course, here that is preface in the book. The problem is that queuing theory, that is a part of the probability theory. It is very theoretical science. Nevertheless, one very clever scientist, we know him, that is Sergei Stepanov, a famous our professor, once told in such kind of auditorium, please remember, he appealed to the students, new queuing system do not exist at all, because we can't produce these systems ourselves. These systems, queuing systems, gives us life, our life, and only application, and we can't go forward in queuing theory without these concrete systems in our life, and especially in telecommunications. That's why this class of systems, I will describe you these systems, resource loss systems with random resource requirements were burnt, let's say, together with the fourth generation of networks. You know that long-term evolution networks is fourth generation and of course 5th generation network. That is a book. It consists of 3 parts. We have also preliminaries and of course matrix analytical methods. That is in the title of the book. And when you know that my friend and very talented mathematician Valery Naumov, that is his great efforts, of course, first of all, just like all school scientific in our university, he developed some original methods in matrix analytical analysis of in queuing theory. That's why I do not pay attention to the part 2, because Valery should present it here, not I am. Sometimes I even do not understand what is he is writing when he is proving some theorem. But part 1 and part 3, I will give you short comments regarding this book. Part 1 actually is devoted to the evolution of well-known Erlang formula, the evolution from the very beginning, when in those times there was the requirements for resources, because the resource was only one, it was a speaking channel, and that's all, and that's all. Then a new item was period loss networks. You remember such outstanding scientists as Kelly, as Kate Ross, of course, for instance, Gary Basharin here in our university. And then we started to apply, and at this level, models of loss networks appeared for the first time. It happened, I think, in the middle of 80th last century. The first time appeared queuing systems with random resource requirements. Let's go on with my presentation. That is of course, everybody knows these two great persons. First of all, Alexander Graham Bell, because without him, I think I could be another person. Yes, of course, because I'm very happy. I'm a mathematician who applied his knowledge in telecommunications. Telecommunications is a very happy world. So it has happened more than 550 years ago. Alexander Graham Bell, first telephone exchange, and then almost in here you can see, yes, the first telephone exchange 1877, and Erlang was born in 1878. My friend Valery Naumov understood that it was something from God in those times, because almost coincides of two events. So Agner Krarup Erlang, yes, of course, thank you very much. By the way, I have been in Copenhagen University of Technology. There is an office of Erlang and his picture with him, yes, and everybody tries to have photo nearby him. And I have, of course, this photo, but of course, he is Danish mathematician, and it is known that a researcher from Bell Telephone Laboratory learned Danish in order to be able to read Erlang's papers in their original language. And of course, the most important work, solution of some problems and the theory of probability of significance in automatic telephone exchange. 1917, it's again some godness took part in this paper. And in this paper, one can find famous Erlang B formula. So that is okay, I will skip some files, I will show you because it's very well-known thing. So that is the task which was solved by Erlang. He found out the probability, blocking probability, when all lines, telephone lines are busy and one more call can be blocked. And the probability of blocking is the metric of interest. So this is the formalization of the task in terms of stochastic of Markov processes. Please, students who are only at third year or fourth year, please, it's enough. It's enough. That is the problem formalization, and the problem is to find the probability that a new call will be blocked due to the fact that all servers are busy. You can try. And of course, here the answer. Well, we say low-mass equations, and the stationary probability distribution, well known for us. That is what kind of Poisson distribution? Yes, finite because number of servers are restricted by a number S, and then we can get the famous Erlang formula. Here it is. This function was called Erlang's loss function, ES of rho, and that is the result he obtained in those years. That is Valery again likes very much this formula. He explains to students that please try. You can calculate the left hand when S is equal to 1000 and rho is equal to 1002. Please calculate. And that is the probability. You should obtain the value between 0 and unity. And that is the method for calculation here. Even one can get the integral representation of the Erlang formula in continuous time. By the way, in 1957, the Russian mathematician Boris Sevastyanov, I have seen him, just like maybe somebody from my generation, proved that Erlang loss formula remains valid and service times have general distribution, not exponential, but general distribution. He is colleague of academician Kolmogorov in the famous work. Just now, they say almost in every paper that is insensitive law, that the result is insensitive for the distribution. But they forget this name, Boris Sevastyanov. They, I say, all worldwide in probability theory. So let's suppose that we have two arriving processes, and the task is the same. That is, I'm coming to the multi-dimensional task. That is the state transition diagram, well known to everybody, and that is the result. That is the result. What is my goal? I can see here again elements from Erlang formula. By the way, P formula. Why B? There is no A and C formula because B is from the word blocking. So again, I can use this function, the same function, for two-dimensional task to calculate the blocking probability for general, in some general assumption regarding the service again. And then, of course, I can get the multi-dimensional Erlang distribution. Of course, everything all these formulas were motivated by the concrete changes in technology from Bell system and the exchanges of the beginning of last century. We came to the time division multiplexing digital exchanges, yes, and then we should generalize the model. And then we again give the following model when we have K capital flows, and we have the same Erlang formula but multidimensional. That is some evolution of this formula. Here we can scope with the calculation, nevertheless, to calculate blocking probability. Here we can scope with calculation of this, let's say, function G sub I. For instance, we can use Kaufman-Roberts formula, and we have iterative algorithm for calculations. Let's go further. Loss networks. So TDM networks, that is about 70th of last century. That is loss networks. I think that Frank Kelly first made calculation for with British Telecom was a customer when planned the telephone network, and he even made a lecture to the King Общества Society of Great Britain for this result, which we can see. And we again here we have a network, and we have requirements to the calls which are coming to the network. It means that type car of customer require some number of circuits, S sub K sub N. That is, let's say, maybe the first formalized from the mathematics point of view task or problem where we can see the resource loss system. But the requirements are not yet random. That is the second generation networks at the end of 80s and the beginning of 90s of last century. What then else? And now loss systems with random resource requirements, that is the formalization of the task. It's better to understand it looking at this picture. We again have several streams. Let it be these streams are Poisson. We have in this model, we have servers. These servers model the delays of each customer which it spent in the system let it be also exponential time distributed. It doesn't matter. Due to the Boris Sevastianov approach, we can consider this distribution also general, but here, customer type car, which will spend new car, it's new car seconds in minus power, power in the system will capture some resources, and we have pools of resources, not discrete but continuous, and fk of x is cumulative distribution functions of this random values x, and that is the state of the art of the beginning of this century, maybe last years of previous century, for loss system with random resource requirements. And what we can have after solving the equilibrium equations, which are, of course, we should introduce additional variables. It's a well-known method, and we can get this formula for analyzing the stationary distribution. Here, one can see the convolution, of course, of those functions, but again, we can see some elements of the Erlang formula. And that is, as far as I understand today, that is, for today, is maximum of evolution of Erlang formula in a very simple, of course, problem formulation. Here, again, the task is to calculate this function, gk, to calculate blocking probabilities. And this task, how to say, is still this problem is still not solved, because it is solved only in two cases, when the functions are discrete type first, and then we can apply, for instance, matrix analytical methods, or I and Valery have one paper where we used the fast transform, Fourier transform, to calculate this formula, but not so with not so big dimension, of course. Of course, scientists know some generalization of this formula. This well-known formula, I remember that this loss system was investigated by Tikhanenko, where we have not fk, f sub k of x function, but we have mutual distribution of two random values, the resources and the dependent time which the customer is spending in the system. But again, this task was solved, of course, not in general case, but nevertheless. That is one more a loss system with positive and negative resource requirements. What is positive? Positive, it means that when I'm coming, I'm taking some random resource, but this resource is positive. But sometimes I can come and take a resource of negative volume. What does it mean? For instance, it means that when I am coming, the pool of resources is increasing with those negative number, actually. It's very interesting task. It was also introduced when we investigated some 5G network system. So that is the first book, the idea regarding resource loss systems. Of course, we say, I will tell you a few words regarding regarding the next book, because all these
queuing theory methods were developed due to some applications in modern telecommunication during last maybe 5, maybe 8 years. First of all, you have seen already this picture. That is the picture of 5G lab Rudean, Advanced Research and Development. You can see it nearby my office. Yes, because without measurements today, which are organized at least at laboratory, sometimes the research is, how to say, is in the air, not on the ground. Because sometimes I should understand what is really happened in the network when something occurs in the outside world. And we have this laboratory, in this building, yes, and we have produced several experiments on this laboratory. 5G networks, I underline 5G network. I think that in Russia, I can 1, 2, 3, 4. I know 4 institutes and labs where you can see such kind of network. Of course, that is network which is answer to 5G new radio standards, please. And the radio interface is based on the national instrument environment. Please, we can, during our conference, we can show this laboratory. Now I have not so much time, but I should tell you that this June we published one more book in Russian, which is devoted to our last 5 years research in the area of 5-6G networks regarding architecture, technologies, regarding methods of estimation and performance analysis of quality of service parameters. We have no list of references in this book, but we have references to our papers. Exactly 100 papers from first quarter of the journal. It means that our team, which was not alone, of course, I will show you a little bit later, and I will explain to young researchers, it is almost impossible to research something in telecommunications alone. It should be some collaboration, not only between different scientists, for instance, engineer, mathematician, system analytic, but between countries. It's very, how to say, very difficult to create such kind of collaborations. I think they are not created, they are born by goodness, because sometimes even difficult to understand why these scientists are coming together to solve some problem. I will show you one very interesting work we produced 3 or 4 years ago. So that is this book. It is available in Russian, please. And it's very important in this book. We, first of all, of course, we started this research and development since last 5 years. And we pointed out 3 main stages of the research, well known to every scientist which is sitting here in this room. First, it is necessary to investigate a specific but quite general scenario of applications of the network, because it is not enough to say that I'm going to investigate 5G, 6G network. What is it? 5G, 6G, 6G, I'm sorry, I'm speaking in almost in Russian. 6G network, it's some, how to say, it's a system. And I can construct a network using requirements of the system which are taken in the international standard. For instance, those standards which were under overview by Professor Amar in the So first, you should understand and should investigate a concrete but specific scenario. Second, you should take from this scenario some system model, those system model which you want to investigate. And this system model, by the way, this scenario can be ultramodern. What does it mean? Sometimes when they say that this task is ultramodern, I didn't believe to this word ultra. What does it mean? It means that this scenario can be, or maybe can be in future. So when I am constructing this network, I want to understand what will be in, for instance, in 30 years, in 5 years ahead. I don't know, but I can construct a model. First scenario and then model. And then investigate this model and to say whether it can be or not. That is the advantage of mathematics, but mathematicians can't be alone in their research. They should be together with other professionals, first of all with engineers. And of course, system model is constructed under some simplification of concrete technical scenario. And the third phase is the stage of building models, of mathematical models, based on system model. And again, I should make some assumption. Of course, you remember Erlang, yes? I think that no one of present here people can imagine that the telephone exchange 100 years ago was not complicated object, very complicated. But as a model, I can depict it in one sheet of paper and to give the formalization of a task to every student after the course of theory of probability. No problem. Of course, after several simplifications. And that is some, how to say, of course, advantage of scientists. And these simplifications are doing, I'm doing with under some requirement or goal. What kind of goal? I should understand what kind of metric I will analyze. Erlang analyzed blocking probability, and he constructed the model which can help him to analyze even, namely this metric, not another metric. That is our idea. So technology, then system model, then mathematical model. Sometimes it's simulation, maybe Monte Carlo as statistics method. Sometimes measurements on the laboratory test bed. But every time, in every kind of, in every approach, I should understand the problem. What kind of metrics of interest I will investigate. Otherwise, I can't construct this model. And we discuss this in this book, of course. So that, for instance, that is two models in this book. One is from the stochastic geometry. We say it's baseline models. Baseline models. I'm sorry. Sorry. I have not so much slides ahead. That is baseline model of stochastic geometry. Yes. That is the task for students. Please imagine you have triangle with random you can say сторонами. Yes, with random sides. Thank you very much. You know two sides and random angle between them. You know only distribution functions of these three values. Please find a distribution function of the third side using, for instance, cosinus theorem. In the textbook of academician Shiryaev, in the textbook, you can find how to only one string to get an answer in an integral form. But when you want to calculate something, you will spend a lot of time. Just the same for this very simple model. That is simplifications of the resource flow system. Just the same. I can give to every student here task, and you can try to solve it, and the solution we can publish in research in the scientific journals. Very interesting task, please. So now regarding the collaborations in the research. It was 4 years ago. We investigated the dynamic multi-connectivity performance in ultra-dense urban millimeter wave deployments. It doesn't matter what are these, what means, but what was the problem? To solve this problem, we created collaboration, which is here, King College of London, that is Misha Doler, Tampere University of Technology, Finland, and there Professor Kuchereva, Professor Andreev, Professor Malchalov, and Rudin University. And that is the task. And that is responsibilities of the researchers for parts of this task. Step one, all of us understood the technology, of course. It doesn't matter. But step one was simple model, and King College defines the system model. Step two, mathematical model after system model. It was at our responsibility at Rodan, and we produced a system model in terms of resource loss systems. But it isn't enough, because mathematical model is very simplified regarding system model. Tampere University of Technology, now Tampere University, produced a simulation model using their own simulator in order to validate the mathematical model, of course, because nobody will believe to any mathematician without at least simulation and better measurements. And of course, after all these three steps, team, Ruden, TUT, and KCL implemented performance evaluation together. What was the task? I will explain to you. That is the task for a 5G millimeter wave network. That is detailed 3D model of the Times Square in United States. That is the moving objects, vehicles, and that is application access points. The problem was how to provide the access to access points from vehicles without loss of quality. That was the scenario. That is the scenario. Then we produced mathematical model. I showed you. That is, I will show you a little bit later. That is resource queuing network with so-called signals. That is the schematic image of this model. And of course, that is the high-level structure of, we say our, because it was a team, of the system-level simulator. That is mathematical model on the left hand from me, and simulator at the right hand of me. And that is the result. Of course, very important thing. This important thing is appearing at the level of system model, because I should have initial data for calculations. For instance, width of streets, height of buildings, and so on, power of signals, and so on. That was a responsibility of King College. And that is the result. That is YSS, that is denial of service probability, and that is traffic intensity. That is the result. And the result was published, my colleagues abroad knows, this famous journal JSAC, that is top of telecommunications journal, isn't it? Yes, with great impact factor, but nobody of us, not King College, not especially we mathematicians, not Tampere University, could not prepare this publication. We solved the task during 1 year, maybe, and 1 year it was the time of revision of this 3 rounds of revision. Reviews wrote first of all major revision, then minor revision, and then only accept, and then only accept. So 2 years. I think about 10 people. 3, I, Evgeny, and Mikhail, 3 bosses. Yes, we do nothing. We are only managing the process, and that's all. And that is without salary. It was only our, how to say, quasi volunteers, yes, in science. Of course, I have salary in my university, but it wasn't a project. We were very interesting. And the result was the publication in high-level journal. It was enough for me. It was enough for me. Of course, this task today, the so-called multi-connectivity performance, is not so new, but that is very interesting thing. You can do nothing in technologies alone, only mathematicians. But when mathematician is getting some result, please ask him, where is your theory? Where is some of theory? I don't know, I have no. I know Erlang theory. Yes, I know Cauchy theory and so on. So if you have theory, please, you are welcome, you're a great mathematician. And here, sometimes we have great results. In those schemes which I explained to you, and that is written in book which I'm representing you. And that is the mathematical model, of course, loss network with the random resource, requirements, and signals. What does it mean? My call is coming to the network. It takes some resource, maybe not only at one access point, but in 2 access points. Both these requirements are random, but sometimes something interrupts my calls. And then, for instance, I want to have more resources. This interruption is a signal. And after the signal, my call can be lost, or the system will give me more resources. That is we say, and that is a new queuing system, because under the system, we know concrete technology and concrete system model. Otherwise, that is some exotic queuing system, which was born in some brain of mathematician, very, how to say, with illnesses. Yes. Can you imagine such kind of system? Of course not, only after investigation of some technical problem. That is some references to our works in mathematics from People's Friendship University. Thank you. And I appeal, of course, to young researchers which are here. Of course, we described in these books a part of our very interesting life in the science. But this life is very difficult, very difficult. I believe that you will be successful in this life. Yes, so thank you very much, Alex. I am not ready to answer questions.
Yeah, thank you very much, Professor Samuel. So today, I know I'm working with Professor a long time, but today I know a lot about the scientific school of Professor Samuel. So please, questions.
Pupil of Professor Gaidamak. You can ask me in Russian. Yeah, and I answer in Russian too. First, 5G is yesterday, because 5G networks are already at commercial phase. In 2020, yes? From 2020 year, yes. And just now we are starting to conduct research in 6G networks, yes? And you know that these empiric cycles, they believe that in 2030 we can realize in commercial phase 6G networks, yes? It's almost the same. 2030 network, yes, Amar told about them. That is the term of the International Telecommunications Union. And 6G is from 3GPP. And what is the question? Future? very good future for us. I will answer you. I am in telecommunications from 1976. In 1972, I entered this university. From 1976, my teacher, Professor Basharin, gave me first money for some concrete task in some project. And from those time, I'm in telecommunications, and I'm very happy, and I think that I feel very good from every point of view. But in the end of last century, my colleague from the Finland, Olli Martikainen, he was at the board of Telecom Finland, and my colleagues understand that is a huge person, yes, and he also was a mathematician. I asked him in 1998, that was the time of second generation networks, GSM. I asked Olli, what should I do in 10 years? That is your question. He answered me, Konstantin, in 10 years, this processor, in those times processor was of such volume, yes, will be here. And GSM will be inside this crystal. So in 10 years, we should be in software. And he was right. It depends on technology. But I say to students in our university, I classify students in telecommunications in three classes. First, researchers. Second, developers. And third, how to say exploitation, yes, because it's very difficult problem exploitation of telecommunication systems. Here in this university, we cannot develop something. For instance, that is Baumka, MFTI, Mira, and so on. We cannot provide knowledge to our students how to exploit these systems. For instance, that is Bonch-Bruyevich Institute, isn't it? Yes, some specialized. And here we can conduct research advantage. So we should think about models. And to do this, if you will learn all three stages, technology, system model, and even simple mathematical model, you will be an investigator. We can't give you here to mathematicians and to natural sciences more because we are not engineers. But here in our laboratory, you can ask, for instance, Amar, you can ask Abdul, Kadir, they are here in this building, and they will answer you regarding the technology. They will help you in the system models. So what will be with you in 10 years? I don't know, because they say that about 50% of specialties in telecommunication industry just now has no titles. We don't know the titles of these professions. I don't know. That is my answer. You should only live in this world, and that's a very nice world. I think that in 10 years it will be 20, 30 networks or 7G networks. It doesn't matter for me. For me, it doesn't matter, because 50 years ago, if somebody told me about such kind of problems, I could kill him because it's couldn't imagine in books of fantasies. Thank you. I will print additional copy of my book, and you can ask him from your teacher, Professor Gaidamak. I will give you an electronic copy only for you. Thank you, Professor. Your question.
Good evening, Professor Konstantin Somalu.
Thank you.
When I listen to your lecture, I feel like I also went along with you 1970s. And
you also remember this time.
Yes, and I also feel like going all the way and learning all the things, whatever we learned those days, it was able to recall. So this talk was sort of a survey of 1970s to 2020, almost 50 years. And the duration which you talk about, that is less than my age, and which is greater than your experience in this research domain. So I'm proud to listen such a person giving a talk and whose age is lesser than the person's experience. So I'm happy to listen your talk. That's my first appreciation part. The second part, the question is,
Thank you.
when
Estimation of my lecture. Thank you.
when you have studied at those time, the people got self-motivated and learning new things without any boundary. There is no destination. We have to get the degree and we have to get the job and so on. So those days you will have your own self motivation to learn many more things without the name, many more different jargons, different things. You would have keep on working and you would have got it, and the name would have come later and so on. But whereas the current generation people, which we are knowing the names first without knowing the meaning of it. So many jargons, we just browse it in the Google and we get, oh, okay, this I know, this I know. So like that, we are in the like a tip of many jargons, but we may not have a very good depth knowledge because we are not sort of self-motivated. It is a motivation comes from the supervisor, or motivation comes from parents, or motivation comes from uncle or aunts. They say you have to do this, you have to do this.
But not from internet.
So my question to you is, could you please give a little motivation to us, what we should do, what we should not do? That's the question.
Thank you very much.
Thank you.
I have, let me tell you a very short story. Please sit down. No problem. Thank you for your. It was in the beginning of this century, again in Finland, in Helsinki University of Technology, or not, in Lapinrantanen University of Technology. Olli Martikainen, my friend, gave their lecture to the students from economy faculty, which were interested in telecommunications, because very good application for economists, isn't it? Because there are a lot of economic aspects in telecommunications. And one of the students, the auditorium was overflowed because Finland, by the way, and just now, by the way, do you know that the third supercomputer all over the world several months ago was installed in Finland, nearby Oulu. It is very digitalized country, very digitalized, with very good technologies and so on. And one student asked him, dear professor, please answer me, how I can be Bill Gates? It was very interesting question, because how I can answer to those students or to you, because that is some philosophic thing. Yes, he of course very clever, and he gave very clever answer to him. You should have only three things. First, you should be in those points all over the world when they give the success. They give the success. But it isn't enough. You remember that aunt of Bill Gates were at IBM company. Everybody remembers, otherwise Microsoft DOS couldn't appeal. So first, you should be there in this point with the accuracy on 1 millisecond at the geographical match. Second, of course, you should be in time. And you should give money in your pocket. And of course, after that, you should be a loser. Is it enough for you? Asked Olli Martikainen to this student. If you have all three of these conditions, then you should be motivated to be Bill Gates. Of course, I can't answer your question because you are teaching your students. I don't know, you have at least 20 years
And I'm, how to say, the leader of it. Huh? Yes. What? Yes, I'm dreaming that I could live together with you 10, 20 years. I want to see what will be in 20 years in telecommunications. I don't know. I'm not sure that I will alive. And you will alive, you will know. That is your motivation. You will alive during these years, during this, let's say, gunfire, and so on, so on, so on, with all obstacles. And you will see the results of your job, your pupils, and you will understand what will be in telecommunications. Because 20 years ago, I couldn't even imagine regarding this picture, isn't it, Amat? What about multi-connectivity in 5G networks 20 years ago? We don't know. So that is my answer to you. Very philosophic, of course, but I'm not Oleg Martikani. Thank you. So, thank you.